Abhijit to give the safety speech.
Hi Abhijit, a fire in charge with safety officer in this Welcomhotel Bhubaneswar. We have two assembly points. One is the banquet, one is the lobby area. We have also fire extinguisher sprinkler system. यूनिट के पास फायर सर्टिफिकेट है, कोई का यूनिवर्सिटी के सर, और यूनिट का नंबर है, इमरजेंसी नंबर है 3. Banquet hall having 500 packs with 3 fire exit with different signages. Unit have smoke detector with different type of detector all over the area. Which controlling device is notifier. Have a safe event. Thank you.
I would like to introduce all the dignitaries present on the stage. First of all, I would like to introduce Mr. S.S. Mohanty, MD and CEO SR Medmet. Next, I would like to introduce Mr. D.B. Sundararamam, Vice President Corporate Services Tata Steel Limited. Next, we have on the stage Dr. Ramanuj Narayan, Director of CSIR IMMT. Next, we have on the stage Dr. P.K. Banerjee, Outstanding Scientist, CSIR CIMFR Dhanbad. Next, I would like to introduce Mr. Tarun Chatterjee, probably the most energetic personality we have over here. He is a veteran of the coal and coke industry and a well-known author and consultant. Next, I would like to introduce Mr. Pratish Sen, a renowned metallurgist and CEO and editor Steel Tech. Last but not the least, I would like to introduce the convener of this conference, Mr. R.K. Sabat. I would like to request Mr. Pratish Sen to deliver the welcome address. Over to Pratish, sir.
Namaskar. Thank you, Ananya, for setting the ball rolling. Very good morning to all dignitaries on the dais, Mr. Sundararamam, Mr. Mohanty, Mr. Tarun Chatterjee, Dr. Ramanuj, Dr. Banerjee, and Mr. R.K. Sabat, and dignitaries of the dais. I see many, and I do welcome on behalf of Steel Tech and on my behalf also to the city Bhubaneswar, the temple city and city happening city. You know, all we know here in India know what does it mean by Bhubaneswar, but the people who are, a lot of people are from overseas delegates. For them, let me tell what is Bhubaneswar. That actually Bhubaneswar is made of two names. One is Bhuban, another is Ishwar. Bhuban is the universe and Ishwar is the Lord. So you are here in the, that means it's the space of Lord. So you are in the space of Lord. A big round of applause for the people who are coming here. Thank you very much. This is the 21st of November 2025 and this is the 21st International Steel Seminar what Steel Tech is conducting. And we do always conduct this seminars, international seminars on contemporary subjects. And this is the one what C4, we're naming it C4, that is coal, coke and coal chemicals. It's a very important one. And we did it for the first time on C4. And that too, the place where it is happening place, as you know, that Odisha is actually growing, and also this is the steel hub of India. You can say it's Pittsburgh. Kalinganagar is hardly 100 kilometers from here. That is a big investment is already there, and some more are coming. So therefore, this is the place where a lot of activities with regard to steel is taking. So we thought that we'll have a seminar here in Bhubaneswar, and our main architect of the seminar, you'll hear from him, is Mr. Tarun Chatterjee. He is the chairman of this entire event. And at this age, I could give you what is the guess, what is his age. Later on we will know, people who know him, so much enthusiastic with his effort and challenge. Of course, Sabat is there. He is the one who is doing all the work out here. Whatever comfort you are getting here, it is because of him, is coordinating. And you know, like this is the one, this is, you see, this is the program what we have. It's a very tight program. Generally, in steel tech is known for this technical thing, not very much commercial, although we want to be, sustaining, but it is not the only effort. The effort is to see how to make this technical discussion a forum where a lot of technical things will be discussed. And here, if you see, we have 3 sessions, and there are more than 20 presentations are there. In addition to that, there is a book release. I think they will do about this. And I'll be very brief. I can go on, but I want to listen from the dignitaries, because we're on the dais. Off the dais, of course, there are people who will be presenting. With this small brief, may I again welcome you all to this seminar. And one thing may I request for the people who will be presenting, the people who will be speaking, to please adhere to the time. Because that is we want to, essence is we want to hear from everybody. People would have loved to give each people around more than time what probably it is will be given now or for this one. But we will be covering this thing in our videos as well as in our magazine. So therefore, please stick to the time so that you can hear everybody off the line during networking. We can discuss further. With this small brief, I once again welcome you all, the city of temples, city of happening place, and the Bhubaneswar, that is Bhubaneswar, as I again mentioned, the place of Lord. Thank you very much. Sangram, where is here? Yeah. And on to Mr. Mohanty, Mr. Sundaram got one, and Mr. Chatterjee, Dr. Ramanuj. This book contains 30 articles, practical articles, and Mr. Sabat. Yeah. Where is Sangram? Is he here? Yeah.
Hard since the past 6 months to make this dream come true. May I request all the authors present in the audience to gather at the stage for the grand launch of the book.
Take the book from your bag. All of us have books in their bag. Please bring it. Yeah.
Can we have a huge round of applause for the authors present on the stage? They worked very hard for the launch of this book. May I invite the youngest author, Mr. Sangram Patra, to formally launch the book. May I request Mr. Sangram Patra, youngest author of the book, to formally launch the book. Also, I would like to invite Mrs. Nijani Nagpur to formally launch the book.
Oh, yeah. My God, we announced before time. Please come to the stage. Yeah, he's here. Yeah. He's the youngest author and he's releasing the book. Take the book up. Go tika dijiye. Yes. Yeah. Maybe round of applause. By the way, he's getting married day after tomorrow. Wish him a good luck. We have all gone through. He has to go through this. Let him be happy for today.
Thank you everyone for the blessings.
Yes. Yeah, one thing before I hand over, I forgot to mention, there are people who are from overseas all the way, come from Austria, there are people from China, there are people from Finland, there are people from Germany, New Zealand, USA, and all the places. So we call a thing called Atiti Devo Bhava. Atiti Devo Bhava means the guest is the God. The guest should be treated with utmost respect, reverence, and in care, as if they are the divine being. This origin, I am not saying, this origin is ancient Indian scripture called Upanishad. It is mentioned there. So people who are from all the way overseas, we welcome you all, and also from India we welcome all our overseas delegates. A big round of applause for all of them. Thank you. Yeah, the people, some authors who could not come. There are some authors who could not come. There is 1-2 minutes or something video if you can play. Kapil Dhara, yeah. And there is one more, it's just sound. Audio.
Today's conference. Special thanks to Mr. Chatterjee, who is a stalwart in the steel industry with his extensive experience in metallurgical coking and the related fields. He has already authored excellent books in the past and on this particular topic also, and I am really thankful to Mr. Chatterjee and the editorial board for giving me an opportunity to contribute in his new book, Metallurgical Cookmaking 2025. I truly wish that I could have attended today's conference on coal, coke and chemicals organized by Steel Tech and been present for the book launch. However, due to my travel to US, I am unable to join. I therefore extend my best wishes for the book launch and for the conference to be a grand success. In my contribution, I tried to cover global challenges, mainly due to the climate changes, CO2 emissions and decarbonization efforts, India's coking coal challenges, and suggested solutions to
Yes, Miss Bass. Yeah, please. He could not come because he is traveling to US and Madam, yeah.
Namaste. Hello everyone, I am Riya Vyas. I am currently working with East Mining Company, AMCO, which is a Russian coal mining and trading company, as a coal market analyst. Now today is a very special moment for me because my article named The Shifting Economics of Met Coke, India's Trade Adjusts to New Norms, has been featured in the book Metallurgical Coke Making in India 2025. Now I want to begin this with heartfelt gratitude to Tarunda and the entire team for believing in my work. This is the second time I am contributing an article, so thank you so much for giving me this opportunity again. Also to everyone present in this wonderful book release event, thank you so much to celebrate this movement together. I'm so sorry I couldn't join you in person, but I'm truly grateful and deeply happy to be a part of this book. Now just a small briefing about my article. So this article explains how India's met coke industry has evolved from its origin in eastern India to the rise of new hubs like Gujarat. Now I have tried to cover almost all the major aspects of India's met coke and merchant cokeries landscape, like from challenges faced by domestic producers amid global dumping to the phases of government support, and finally the new 2025 import quotas and the ongoing policy tug of war between local cokeries and steel makers. Hope you will enjoy reading this article. Again, thank you so much to Tarunda and the entire committee for giving me the honor to contribute to this meaningful work. Thank you so much.
I would like to invite Mr. Tarun Chatterjee to share his thoughts with us.
Yeah, he's the main architect of the chairman of the session, and about the book, because like we thought that one way we are going about the book release, and he'll just mention thereafter we'll call our team to address.
My friends in the dais, my friends in the audience. I come from Silicon Valley of India. I am from Bangalore, and where I live a very uncomfortable life, social life, because there everybody is a tech. And one thing, while interacting with a young group of people, I came to know they deal with information. And I dared to ask them, is there any classification of information? They said, what classification? I said, like in coal, we call it hard coal, semi-soft coking coal, soft coking coal, do you have this classification? Hard information, semi-hard information, soft information, so they laughed at me. And then I said, I'm going to Bhubaneswar to deliver a talk. He said, Mr. Chatterjee, start your meter, charge money. Because here in Bangalore, everything is tradable, information is tradable. I said, I'm going to a knowledge session. Knowledge is not tradable. There's a pleasure in knowledge sharing. So that is how we are all here. We are sharing our knowledge. I requested Devjani to deliver this talk. She has prepared the talk for me. And I will just read out what she has written. Allow me to take a note. Give me a minute time. Yes. Yeah. Now, steel making, India is growing, and there is a need. Today we are processing about 100 million ton of coal, metallurgical coal, to meet the demand of the steel industry. In another 4 or 5 years, it is going to become 130 million ton. So this is a challenge, this is also an opportunity. The new geopolitical scenario has opened up. Availability of coking coal from, earlier it used to be only from very few sources, 4 or 5. Now it is almost a dozen sources from different countries. This is also a challenge and also an opportunity. A big change has occurred in this century, turn of the century, where the new technology, the stamp charging, not new technology, stamp charging was done earlier also in Tata Steel, they pioneered it, but it became extremely popular. Stamp charging is a game changer. It is being applied not only for recovery, also for non-recovery ovens. And India also has developed the same technology. It is a little smaller scale than what the Chinese are doing or the Paul has done. We are also becoming extremely energy conscious, and so coke dry quenching plant, CDQ from various technologies are also available in this country. Now, this is a unique country in the whole world. India stands where technologies from all across the world are available, including our own, both in coke making as well as coke dry quenching. And that is how, in this context, this conference is extremely useful for us, that we are able to create a knowledge sharing platform. Now, we have given the main theme of this conference as a philosophy. As a young boy, as a 25-year-old, in Bhubaneswar steel plant, where I was working, I came across an article in Coke and Chemistry, and where I came to know that the Japanese calls it philosophy of coal blending. The West had called it science and arts. The Japanese came to the point of the word philosophy, which is a combination of all forms of science, arts, engineering, and that is how the word philosophy has come into our mind. It's a combination of technology, economics, science, and engineering. And now, my part, let me share you some breaking news that duty on made coke, Government of India has introduced in this Sunday, and which is a great relief for the merchant cokeries, which were all in a very difficult situation. They were all performing 50% capacity. So I hope this will give them a new lease of life, and a lot of economic activities will start in the merchant coking section, including creation of new assets. Second great news is that Tata Steel has completed 10 years of its work in Kalinganagar. I spent my precious 4 years in Dhubri building up Neelachal Park way back in 1996 to 2000. A big compliment to Jindal Steel for commissioning their 6.7 meter height stamp charging coke oven battery. A great compliment to the tallest in the country. A very dynamic decision. Fantastic. And third, this is a conference. This is a great event of this week, which I mentioned to you. It is first of its kind, not only in India, I'm not sure, perhaps in the world even. I've seen many international conferences. I don't know whether they are able to bring out a book like this. And a final announcement on behalf of Steel Tech that we'll again meet you in 2026, 2027, 2028, so this will continue. So we are creating a trend. Thank you everybody. Thank you. Like this. And a final announcement on behalf of Steel Tech that we'll again meet you in 2026, 2027, 2028, so this will continue. So we are creating a trend. Thank you everybody. Thank you.
To introduce our distinguished guest, Mr. D.B. Sundaram.
Yeah, I am just consulting that. This is, I would request, he has come all the way. He has a meeting in Delhi, he has to fly back. But his love for Steel Tech is so much. When I requested, he said that I'll come at least for a few minutes. So I request Mr. Sundaram to address the audience. Yeah, thank you very much, Mr. Sundaram, for you.
Good morning, everybody. All the dignitaries of the dais, Mr. Tarun Chatterjee, Mr. S.S. Mohanty, Dr. P.K. Banerjee, Dr. Ramanuj Narayan, Mr. Rakesh Sawant, Mr. P.K. Sen, the dignitaries of the dais. I could also see my former colleagues like Mr. Haldar, who is the last word for the current topic which we are now going to discuss in Tata Steel, and Mr. Deshpande, who has been all along worked in coke, cinder and iron. After seeing these people, I'm a bit nervous. And also we have got our former Tata Steel colleague like Dr. P.K. Banerjee and all, who have worked whole of their time in this, particularly on this topic. But yes, I would like to mention that the way India is looking for Vikasit Bharat and Atmanirbhar Bharat, Make in India. So definitely enhancement of steel production is the backbone for these dreams to be fulfilled. That can only happen when we have raw materials. Fortunately, we do have enough iron ore, which is a major ingredient for BF technology. But at the same time, we are not that fortunate when it comes to metallurgical coal. And as all of you appreciate that for hot metal, the cost, the portion if I look at, almost 35 to 40% is from coking coal as well as coke in hot metal making. And India is unfortunately not blessed with good quality metallurgical coal. So that's the reason why Tata Steel, which has started its operations in 1907, almost 119 years of steel operations we are having. And as mentioned by Mr. Chatterjee, our second steel plant came in Kalinganagar, which has just completed 10 years, which is a 8 million ton steel plant. So today we have close to 25 million tons of steel making capacity in India. So we introduced stamp charged batteries only to use our own coal, which is not a prime coking coal, it's a medium coking coal. So since the speakers are going to talk about these things, I would only like to share the experience what we have in Tata Steel. So I think we're 26.5 million tons of steel making, roughly 15.3 million tons of coking coal is being used by us, and out of that 3.4 to 3.5 million ton, means roughly 20% is from our domestic sources of medium coking coal, West Bokaro, and some small portion of prime coking coal at Jharia. So, but as all of you appreciate that this coking coal, as mentioned by Mr. Chatterjee, also includes prime hard coking coals and semi-soft coals, whereas non-coking coals are primarily PCI for only injection. So the share of imported coal in the blend is as high as 70 to 75% for Tata Steel. Unfortunately, for many of the steel plants in India, it's as high as imported coals are almost 100%. So when we talk about Atmanirbhar Bharat, then I think the topic which today we are going to discuss is going to be of utmost importance and is going to be a game changer for us. So I would also like to share one recent experiment which has been done by our raw material technology group. We have found out some low ash, though it's not a metallurgical coal, but low ash coal. Almost when I talk from Indian context, low ash, I'm talking about 20%, 21%, because if I go to Australia or somewhere else, when I say low ash, then they think it is 3%, 4%, or 6%, but it's not so, because the medium coking coal which we get in West Bokaro, that varies from 21% in the top seam to 35% to 40% of ash in the bottom seam, and we bring it down to 70% with definitely loss of yield, and we are fortunate enough to maintain a yield of 40%, but varies from 16 to 17%. That's the reason why I said 21% is in a way, if a raw coal if I get, that is a bit good coal. That we have experimented, we have washed in one of our washeries and we brought it down to 10% ash. That now we started using as replacement in PCI. It's not 100% because the experiments are on. We started, and also in coke making also we started using almost 3 to 5% blend. Because there are some coals, though they are thermal in nature, they are not metallurgical coals, but we have seen that given the 100% coal blending, 3 to 5%, maybe up to 7 to 8% we can use. If this experiment is successful, I think then that is going to be definitely a game changer for entire steel industry in India. And also the way I talked about stamp charging batteries, because of that only, at one point in time, when our operations were only 3 to 5 million ton steel operations, we were using West Bokaro medium coking coal up to 50%. Even during COVID also, in Kalinganagar we used up to 57% of medium coking coal of ash, varying between 15 to 16%. So the balance we need to definitely make. We need to see how we are going to maintain the parameters, and also how can we contain the cost. As I mentioned, this is going to be the high cost in the entire blend of hot metal. So as I mentioned, the topic is going to be definitely of interesting to every one of us, and the way we end of this conference, the way we are going to make some recommendations and the points, I'm sure that definitely we will take it up with the concerned ministry in Government of India and see to it that how can these conferences findings would be helpful in making Atmanirbhar Bharat and also making India more successful. Thank you, and wish the conference all the best.
Pratish sir to introduce Mr. S.S. Mohanty.
Thank you, and I think he needs no introduction, Mr. Mohanty, and he is my mentor. Big round of applause. I tell when we'll do it in Odisha, so he said that we'll make it a grand success, and you'll see the audience, you see the one. So he is ex-sale director projects, and he is also that chair. He is the president of IIM, ex-president, former president. He is also like CEO and MD of SR Minment, and he is also part of Dr. Steel, is the editorial board. With the brief, may I request you?
Good morning to all of you and the distinguished guests in the dais. As I said in the beginning, in the morning, Dr. Chatterjee is the fulcrum of this event. We are all people are here, and Dr. Ramanuj, Dr. Raman, and Pritish, Dr. Banerjee, and Mr. Sabath, and lot many preliminary distinguished people who are here in the audience. In fact, with Priti's, I've been associated for a long time, and in fact, everybody who are looking here, maybe most of the people in the hall here, maybe around 80 to 90% people, either I'm directly or indirectly involved. So, and as Priti said, I don't want introduction, but I know many of you personally, so I believe that I will not speak much about me. So, when Priti is organized this, and it's one of unique kind of event being organized today. If you look at for last 3-4 years, and I've been participating in many of the international, national in steel and also in metallurgical development. I can tell you this type of event doesn't happen. First of all, the world is talking about gaga about decarbonization, and we are talking about green steel, and organizing in the context of that coal and blending and all these things, and going back to all the the evolving of the coal industries, what we are going to do that out looks little bit of out of place. But to all of you, let me just tell you, only a simple statistics of only 2 lines can convince you that this event is more fruitful, more relevant, and more useful, at least I believe up to next 50 years. 50 years, 5 decades, too long time. Why? China produces almost 1100 million ton of steel. Maybe they are reducing because of this. And India produces 150 million tons. Total world produces 1800 million tons. And both the countries, as I said, they do not have the gas availability to go for DRI and EF, we were talking about decarbonization and whatnot. So the coke oven will remain as long as BF, BOF technology production constitute of course 70 to 80% of our production in the entire universe or world, mostly in India and China. So what relevant it is important. Going back to my background, I am not a coke oven expert, but I have managed at least 35, 36 coke ovens in Steel Authority. One in Neelachal, I think with Mr. Chatterjee established. I have visited all the ovens, ovens, batteries in Tata Steel, JSW, JSPL, and everywhere. And of course, in some of the places like in Japan, etc. Why this is to my contribution to this seminar will be, and let me just also share one information. As we are establishing here and discussing here in this hotel, in Mayfair for last 2 days, Steel Ministries are conducting a Chintan Shivir for how exactly you take the steel industry to a high-tech industry in terms of AI, machine tool, and everywhere digitalization is a part. I think everybody in the steel industry also, right from the Ministry of Steel to Steel Secretary and different organizations who are policymakers and who are all are here for last 2 days, yesterday and today. So, in a contrast, we are talking about a technology which we are able to establish right from the beginning, and at least I have seen in my entire career, the acting MD of the Vilai and also the MD of Bokaro, Director Technical of SAIL, Director Project and whatnot, Director except still Chairman of the SAIL. I have been able to see most of the pain that I get for my production and also is right from the coke oven areas. And because I think I saw as well go ahead and finding out how to repair my coke oven well, because coke, without coke, BF route is absolutely zero. I mean, you just understand that importance of this. People have understood this. If you are as an MD of a plant, you manage your coke oven well, imagine that everything goes well. That's what my understanding is. Mr. Haldari is there, Mr. Deshpande is there. I think everybody knows about it. I mean, though we know about how important it is, but we also understand that we neglect it. And that is one of the reasons we talk about decarbonization without understanding that this is the requirement for next 50, 60, 70 years. Never know. More important is, today's topic as I am going through, I saw many of the things are in the right directions. Yesterday I was in a seminar talking about the energy transition. It's not a green steel. If in India you are talking about 2.2 as a pipe of green steel benchmark, you are going down to 1.6 has been defined by green steel taxonomy by Minister of Steel. We are transiting, we are green steel energy transiting to the green steels. That's what our efforts should be, that's what our concentrate should be. And today's seminar I was going through all the topics written in the book. I can tell you everything is discussing how to make it more efficiency, how to emission will be reduced, how to effectively utilize your automation, digitalizations, AI, machine tool and whatnot to reduce, make a coke emission free, whatever possible to the great extent, and reduce your carbon dioxide emissions in the steel making process. And that's what we are today. If you are today, somebody talk about we are immediately transiting to DRI, EF route in China and India, it's not possible, let me just tell you. Even I have visited China, many of the steel plants, they are one of the most efficient steel producers today, if you ask you. But still, they are going to DRI and all, it's a very gradual process. It just doesn't happen like that. Hydrogen steel making, we are still trying, and Venkataraman will also agree with me, we are trying in a very hydrogen also, they have introduced some players from the blast furnace. They are very, very nascent steels. If you ask me today what is the green steel production today, I will say almost nothing. If you are talking about Stegra producing 2.5 million ton in Sweden by maybe 2027, maybe 2.5 million ton, then going to 5 million ton, producing almost 7.5 million ton. There are so many challenges. I will not discuss all these because the seminar is here today and Pritish also has kept a time limit for 5 minutes. So, having said that, I understand this is a very, very relevant topic of today. And if at all we find solutions for the steel industry today, running so many ovens, I can count the at least number of coke ovens of batteries operating in India today. I am not talking about very small one, but big integrated players, it will not less than 70 to 80 million, 80 batteries, isn't today? Maybe around 60, 70 like that. So if you are able to think that like rebuilding and the new coke oven batteries, stamp charging, and whatnot. We are talking about many of the technological intervention in the coke oven technology, so that we are going through an energy transition also here in coke oven, which directly impacts by the steel making carbon emissions. So with these words, once again, thank you very much for giving me this opportunity to say a few thoughts with you. Thank you very much.
Don't do lighting up the lamp and all to save time, a lot of things. Who doesn't know Dr. Ramanujan Rao? He is the director of IMMT. You are the ex-Tata Steel and request him to address. Yeah.
Jai Jagannath and very good morning to all of you. On the dais, the decorated dignitaries, starting from Sri Sundaramanji, Monty sir, Chatterjee sir, Banerjee sir, Sawat sir and Sen sir. And in the audience, I can tell that from India and overseas, the technocrats, the marketing persons and all the delegates that who makes the event important. So my respect to all of you that you have come in a big number. So I think then the order of our since I have always he give me an order that you have to come for this seminar and he will not understand that how I will be linked to those things. But given an opportunity to lead CSIR IMT and coming from IICT, Indian Institute of Chemical Technology, Hyderabad, where I have been earlier, and then Sundaraman sir has left me. I am also a alumni of Tata Steel. So today's topic, the moment everything is seen, that a great man, that a steel tech is doing a great job for our nation. I was one of the beneficiaries when I was at Tata Steel. I do have one article in a steel tech that was on automotive printing. So the type of things that in today's era everything has become AI/ML, but still a great textbook today it has come out with Chatterjee sir, then Devjani and all the team members that whoever has contributed, our Banerjee sir who has contributed, So a great things of whatever I have seen, I have scanned through. Then coming back to the topic that coal, coke and coal chemicals, how I am fit. CSIR IICT was one of the leading laboratory for CO-based chemicals in the long time back, and even our coal gasification plant, we were the first CSIR laboratory at IICT Hyderabad to supply that briquette and chemicals into all the places. But over the years, that has been ignored with a new system. But once again, Steel Tech has brought this topic again. It is very, very important. If we are looking for sustainability into the picture, everything has to relooked upon. And I think that this coal-based chemical is resurgence of this area. If you will think about that coal-based chemicals or coke making, that today, but most of our book of today, what has been released, that is covering the stamp charging and coke making. And I thanks to Tata Steel, when I was working there, I have seen all the processes, including the Jamadoa mines, where I have gone inside the coal. So if people have taken out diamond from coal, now it is our responsibility as a researcher that how we are going to make non-coking to coking coal, or can there be a blending? Today, once again, second topic is philosophy. So let me talk to the philosophy, that what philosophy can go into this. If today sustainability, look upon, friends, that when you will see the complete value chain of the CO-based chemical, our biomass also produces the same thing. And as one of the experiments, we have put a plant of the biomass conversion to chemical at Navrangpur in Odisha. That place, you take any biomass based on the moisture content, you can make a small briquette out of that. And if you are putting that briquette into the fluoridized bed, you can able to see the first product is your gas, and that can be collected, that has been shown, demonstrated there. Then second one is your biochar, which can be a good blending medium for this purpose. And third is a liquid, that what comes in the coal-based chemicals also. And that has a 3 fragments. First fragment is the ingredient for the making organic chemicals. Second fragment is a snake repellent. And third fragment is the biotar, and that our laboratory at IIT Dehradun has put into, with the help of CRRI, Central Road Research Institute, how a biotar can be blended with the normal coal tar for making a green road or for the pothole filling. So this is the opportunity. This place we have to look into the complete sustainable picture. In the decarbonization mission of Ministry of Steel, I was on the part of the making that how biochar can be used for the making of the steel. And India has a resource. We have to bring together. The problem is that we are not taking risk. We are complacent that any process, because a lot of investments come, therefore we are not taking risk. If we can take risk, if we will apply disruptive system, definitely a good thing will come. And what is the mission of our Steel Tech, that will be successful, all young generation can do that. Coming back to my institute, sir, that some of you, if you are able to get time, it is only 3 to 4 kilometers away from here, and we are putting coal gasification pilot plant, which will be ready by March. It will be under operation, and we are doing this for 2 purposes. One is making hydrogen-based DRI, that with a fluoridized bed, or directly it can go for the hydrogenation of that. In the hydrogen-based DRI, we are also putting vertical shaft. We have the other things, and a straight gate pellet plant in making pellets, because our Indian ore is getting of low grade, and as a research institution, we have to take care of that. So a lot of support is coming from the industry, and I hope that our mission for hydrogen-based DRI will be very, very successful. And in the end, because time is not that much, I can talk on and on. It will go for chemicals, and I myself is a polymer man. And if you are going to blend with the thermostatic system into your own coal, that your heat will increase, your pollution will be reduced. There are a lot of things how to make porous coke out of non-coking coal. So we are also taking a mission on how to make coking, non-coking coal to the coking coal, and there are a lot of opportunities are there. If challenge is there, opportunity for we researcher, we have to, our blood group should be positive, and our degree should be calm. If our mind is calm, if we are positive in our approach, this will be the complete thing that whatever philosophy today we are talking about, we have to keep positivity, we have to make eco-friendly system, we have to do the sustainability, and then only our country's dream of decarbonization in the steel sector, then the Viksit Bharat or Atmanirbhar Bharat will be fulfilled. Then coal, coke and coal chemicals, since all of you are there, another C is missing, collaboration, and I think the basic reels behind this all 3 C's or 4 C's, 5th C will be collaboration, cooperation, and let us not compete, make cost-effective technology, so where the management Subramanian Sahab can take it and Tata Steel can apply. And I can tell while working as a Tata Steel, one of the most R&D friendly organization in the country, lot of investment has been done, and we owe a great gratitude to Tata Steel for training us. So thank you, Sen Sahab, for giving the opportunity. I wish this conference a great success and more collaboration, more effort should come out. Jai Hind, Vande Utkal Janani.
After this, I would also like to invite Mr. Amar Patnaik to honor our dignitary, Mr. D.V. Sundararaman. Next, I would like to call Mr. Amar Boundra to honor our dignitary, Mr. Ramanuj Narayan. A big round of applause. I would now like to call upon Dr. Amitabh Shankar to honor our dignitary, Mr. P.K. Banerjee.
Have the opportunity to hear Professor Banerjee. You know, this big full session is there. So I did not request him to speak in this one because we want to hear more. A big round of applause for Professor Banerjee.
I would like to call upon Mr. V.M. Shisani to honor our dignitary, Mr. Tarun Chatterjee. A big round of applause for it. I would like to call Mr. Rajkumar Rajput to honor our dignitary, Mr. Pratish Sen, whose efforts have made this event a grand success.
I think all let us stand together for a photograph.
Last but not the least, I would like to invite Dr. Devjani Nag to honor our dignitary R.K. Samit sir.
on, it is 10:10. We have 5 minutes, but we should start the session one right now. I request Anna to lead it.
Business of the day. Let us move to session 1 now. I would like to invite JSW Steel team for their paper on advanced statistical method for coking coal selection at JSW Steel. May I request JSW Steel team to come upon and present.
Coking coals are imported, and since the capacity is increasing, the challenges of supply chain and natural calamities also challenges. So coming to domestic coking coals, though we have some domestic coking coals available, but washing capacity is the limited there. So we are also seeing on that aspect. So presently JSW is importing coals from these countries, majorly from Australia, Russia, Canada, US, and recently from Indonesia also we have started. So as we know, any coal making person, when the coal is given, we try to see its properties based on our experience and all, mainly you can say proximate analysis, rheological properties, plastic properties, and reflectance and all. So that itself we have been using coking and non-coking. So we have just introduced a new called semi-soft coking, which is partially replacing hard coking, semi-hard and inerts, all three. And we are also diversifying our supplies from all the major coal suppliers. So we are getting the bargaining power on that. And recently we are using the Russian coals also. And in non-coking coal, though we have a liberty of importing everything, so we are taking non-coking coal as a green delayed petroleum coal, which is beneficial in ash and volatiles. So this is the basic blending. We have all the weighted averages of all the coals, except for fluidity, which is a logarithmic average. And with as a JSW, we can say we are the first one to introduce Canadian tech coals into India. Because of its different rheological properties, they are having low volatile and low MMR, but still they behave as hard coking coals. And we are using the Mozambique coals also. Recently we have acquired a stake in Australia and US coals. We are using Russian coals from 2018-19 we have started. And New Zealand coals we are using very less because of high sulfur. And domestic coking coal, as I was mentioning, we are keen to use the domestic coking coals, only the washing capacity is the limiting factor. So these are the trends you can see, how JSW has decreased the hard coking coal percentage from 54 to 31 over the years. And that is also geographical distribution. Majorly Australia was our major component, now slowly it is being reduced. These are the things which we have achieved with by statistical methods. So this is the composition of the blend and blend volatile matter which we maintain, and this is the coke quality what we are getting. So conclusion is, by adopting this new method, we are gaining cost benefits, bargaining power, new coal selection and geographical diversification. Thank you.
Thank you, Sidling. What is your target CSR for the blast furnace for different?
New furnaces, blast furnace 3, 4 and 5, whereas 1 and 2 are little of low volumes, so here 66, 67 is also acting good.
House is open for questions. If anybody.
Yes sir, yes sir. Presently we are getting 68 CSR with 31% HCC. 31%? Yes.
This HCC, can you please explain what kind of HCC coals which are contributing to 69 or 68 CSR?
Yes, yes. The major part is Australian hard coking coals from BHP like Illawarra and Bhubaneswar.
No, these are prime coking coal. I am talking about the maximum percentage of HCC which you are using, and you are in the result and you are getting CSR of 68. So what is that HCC codes?
That's what 31% you are telling.
What is the name or?
That's what Bhubaneswar, Illawarra and all.
These are prime hard coking.
Yes.
So,
HCC, hard coking coal grade.
Okay. What about prime hard coking coal?
There is only one hard coking coal, HCC.
Yes. Then that would lower than that which coal you are using? Semi
hard coking coal.
What are those?
That is high volatile like Castrol and US Vents.
Okay.
And in that also one more low volatile.
What is your blend VM?
26, around 26. Stamp charge, all are stamp charge.
Good morning, sir. Myself, Manish Kumar from Vedanta ESL. My question is, how much percentage pet coke you are using in your blend, and what is the constraint which is restricting the pet coke percentage?
Well, the usage of pet coke mainly depends on the sulfur content in it. So there are different pet cokes available, varying from 1% sulfur to 6% sulfur. So whenever you are using 2% sulfur, we have used up to 8 to 9%, around 8 to 9%, with 10% volatile matter in it. And actually the problem is only with sulfur, rest are all benefit only. Low ash you will get, and you will get high yield because of low volatile.
So how much percentage you have gone up to?
Up to we have gone to 12%.
Considering the other coal having low sulfur, right?
Yes. Okay. So overall blend sulfur should be maintained below 0.65 something.
Okay, thank you. One more question I have. So what kind of semi-soft coal you are using?
Semi-soft is basically of high volatile and low MMR. MMR of 0.6, 0.65 and volatile of 39 to 40 with 100 fluidity.
Okay, so it is not HFCC coal, it is kind of
neither
only soft coal.
Yeah.
Okay, so what percentage you are using?
That we are using up to 15%.
Okay, that's good. Thank you.
Sir, one more question, please. Since you said volatile matter in the blend remains 26%, then what about your yield or coal to coke ratio, specific consumption, what you are getting?
Coal to coke ratio dry, when you consider dry, it is around 1.38.
What about wet basis?
Wet, because we are operating all CDQs. Our 100% is CDQ, so it's around 1.5.
Hi sir, this is Shivam from S&P Global. You spoke about import diversification in one of your slides. So what further origins is JSW exploring in the short run? And when you do so, is there any other metric besides chemistry, like in exploring origins, like is cost a factor, is supply chain a factor in that?
Yes, since it's a continuously evolving story, so always there are exploration is continuously going on. Though we have also identified new coal sources, but there are logistic constraints like Mongolia. Mongolia is having a good coking coal deposits. But since it's a landlocked country, they cannot export these coals to other countries. So likewise, we are continuously exploring in Mozambique also, Indonesia as well. So it's a evolving story. It keeps on continuing. And after getting the properties, again we will run our program where it can be best suited into our blend.
Are there any other origins on the radar right now?
Right now, only Mozambique and Indonesia are the new one, apart from the existing ones.
Sir, CSR 68, so how much is CRI, sir?
Around 24, 23.8.
Good morning, sir. Pradeep from CLRD here. Actually, I want to know, you have come down to 31% of hard coking coal. From 51, 52, you have slightly reduced. So what are the properties in coal blend which have changed?
That's what the art of blending is, that without changing the properties, we are able to.
How you can, since the rank is hard coking coal and hard coking, all these.
Because as I said, of late we have started using semi-soft coals of 0.7 rank. So that we have compensated by using high rank coals from Mozambique of 1.37, 1.36. Both are in what you can say contradictory in nature. One is low VM and high MMR. The other one is high volatile and low MMR. So since earlier in our we were using 45% HCC, that semi-soft coal itself was not present in our blend. So when we introduce that semi-soft, then we have a liberty to use high rank and low volatile coals, maintaining overall blend we have around 26%.
And all other properties like CSN, TGK,
Yes.
all are similar.
MMR, volatile, FSI, fluidity are within the ranges.
No changes in coke quality?
No.
Thanks, Siddharth.
Thank you.
Just one
Thank
minute. Here, come here, please come here.
A big round of applause.
So, Dr. Amitabh Shankar will present it.
Hello. So topic of our presentation is discipline in the coal field management, and it has been authored as Amar Sir by Amar Sir, myself and Manish Kumar Pandey, all from Tata Steel. So this is basically the content of our presentation. So coming first to the objective of any coal field management or discipline, first we talk about the quality required by the blast furnace as a end customer. So we look for or we target for the good quality of coke, basically indicated by the CSR M40, then the coke mean size, and as well as low acid sulfur, as we also discussed in the last presentation. Sulfur is also very, very important, especially for the downstream process. Apart from that, balancing cost and the quality, because after gaining the quality of the blend and then resultant coke, we must look for the cost. That can be achieved by balancing properly the low-grade coals, maybe of high ash, maybe domestic in nature, and imported coals, and at the same time by maintaining the coke quality as well. Then we also need to look for some sustainable solution actually by maintaining low VM, so that we can maintain or we can get more of coke yield actually, because that will yield lesser of requirement of coal. And then also some strategic and scientific approaches by looking at using more of operational expertise, scientific analysis and strategic planning, so that we can get the right blend. Now we also talk a lot about the different type of the coal, because whenever we try to design the blend, we must look for what are the different types of the coals available. So in the market, there are many ways to categorize the coal, but basically we can categorize the coal like one is hard coking coal. So one is the hard coking coal with very high CSR, 66 plus. And sometimes also we have medium and semi-hard coking coal. Sometimes we also call semi-soft coal. So which has CSR roughly 55 to 60. Normally we get hard coking coal. Then semi-soft or semi-hard coal we categorize between 45 to 60 CSR. That will be higher here. Then the last category is weak and non-coking coal. In the weak category we have a kind of semi-soft coal with very high VM, and non-coking is basically the PCI coals. So the weak and non-coking coal is very important in the sense that it helps to get more of cold strength of the coke actually. Maybe have 40 mean size and all those. Hello. So this combination of all this gives us the right quality of the coke. Steps in the coal belt management actually. The first thing what we need to do is the proper categorization of the coals based on the typical specification or the load total analysis or maybe the incoming rake analysis. We need to see what kind of coal is expected actually in all the categories. And apart from that, HGI is also very important, and in the last presentation also we have seen the origin of coal is also very important. Many times we find that the coal property is more or less similar, but origin makes a lot of difference actually because it decides your compatibility of the coal in the blend actually. Then at the same time, the valuing use is very, very important. The valuing in this concept is basically to compare a particular coal with compared to the other peer coals in the same category, with respect to its chemical properties as well as cost and also the quality. Then based on the properties and other available information, we must design the blend properly, look at the historical data, how it is performed, particular coal performed in the past. If you are designing a blend, similar blend, how it is performed in the past. Do some predictive models, try to make some models based on which we can predict what is the expected coke quality, and finally do the pilot scale test. And then once we have done this, we should continuously try to do the stochastic. We can see the height is roughly 10 meter, the length is 40 meter, and we can keep around 75 kT of the coke. Now this is something what we are talking about. For the same storage capacity of 600 kT coal, we need the footprint of only 20 in case of vertical storage yard, so which is 1/4 of the compared to the conventional storage yard. So we can say this is a typical picture of the vertical storage yard. Stacker is at the top and the reclaimer is at the bottom, so it is basically independent of each other. So this concept was 100% in-house actually by Tata Steel, and this is the first time in India. And because of the compartment between the two coals are completely by the concrete wall actually, so there is no chances of physical mixing, and overall footprint as we discussed is roughly 0.26 times of the conventional storage yard. If you see what are the major differences actually, for the same staking height, in case of vertical storage yard, we can go up to the 33 meter as it is 14.5 meter. And also for the same storage capacity, we can keep almost 3 times of the coal actually. And stacking and reclaiming, if you see, it is both are independent, unlike the conventional storage yard. And also we can apply the FIFO thing, which normally a challenge in case of conventional storage yard. No physical mixing, and it is very important in case of the moisture control during the monsoon period, where the moisture goes as high as 12.5 or 13%. Then you need to reduce your pushing, and coke production is getting impacted. And this is the actual site photograph of Tata Steel Kalinganagar, where the vertical storage yard is in progress. Maybe in a year or two it will come into the existence. So with this, I come to end of my presentation. Thank you very much.
Chambers are divided with the walls.
So length of that
Each is having that capacity length is roughly 20 to 30 meter. So there are 16 chambers. So totally no mixing at all.
And how do you manage this for the rain?
Pardon? Rail it will come as yard, and then at the top there will be stacker which will stack at top.
So second question is what is the yield maintained in your company?
Yield?
Yes. Specific consumption and yield, wet basis.
Coke by coal ratio roughly, it varies. It is roughly 74 to 75%.
74 to 75.
Yeah,
what
coke by coal ratio.
No, specific consumption, coal to coke ratio means 1 point.
Yeah, for one, I mean 1 ton of from 1 ton of coal we are getting roughly 0.74 to.
You can inverse it. Just divide 1.4.
Typically we will do like this actually.
Yes.
In case of heat recovery ovens, we are slightly on the lesser side because of the higher burning loss.
Correct. And what will be the blend VM you are maintaining?
It depends upon. For heat recovery ovens, we are 22 to 23.5. For normal stem battery, for Kalinganagar, we are slightly on the higher side. For other locations like Jamshedpur, we are trying to maintain 24 to 25.
Yeah, thank you. Because that indicates what will be our yield.
Yeah. Sir, one more question. What is the capacity of that each vertical slot, holding capacity?
It's 33. It's roughly 33 to 34 KT, if I recall. Yeah.
Kilotons?
Yeah, 1000 tons.
Yeah, it will close to that.
Directly from stacker it is unloaded into this vertical silos or from yard?
So it is under construction. This is a concept we are doing first time. It will be directly, not silos. From the wagon tippler it will come here. From here it will be reclaimed and go to silos.
Reclaiming in the sense bottom discharge, I think.
Yeah, bottom discharge.
From there again you are taking it to silos where the actual blending takes place.
So this is the solution for the storage. We have a shortage of space in TSK. We cannot have large piles. And secondly, in the monsoon we were having a tough time. Because covering the tarpaulin covering is one of the solutions. But once we cover it and going and open the tarpaulin is a highly hazardous. People get slippery, especially during the rains. So we have switched over to this solution.
Expected by when it will be in operation?
By end of next year.
Okay, thank you, sir.
Shankar, I have one question.
Sir, boliye sir.
I have one question. I'm curious to know that in Neelachal is park, coal stockyard, we sacrificed one stagger come declare and when we were carried discharge of coal and we were wet. Are we making any change in that? We didn't have money, so I had to sacrifice.
Sir, for that we are considering a separate yard now. Yes.
That's good.
But not vertical one. In Neelachal, vertical is not initiated as of now. It's for TSK only. So yes, sir.
I have only one query. Yes, in case of coal coming with high moisture, sometimes it happens during monsoon. Do you have a dewatering arrangements inside the bunker, or do you unload the coal outside till it reduces the moisture?
जैसे इसका प्लान यही रहेगा कि उसमें हम लोग रख देंगे और it will be covered तो further rain से वो moisture नहीं आएगा उसमें. We'll keep it. That's the plan, sir. अलग से नहीं रखेंगे sir.
But you said that you will directly unload it into the silos. It is kind of silos.
नहीं सर, वैगन टिपलर से यार्ड से ही आएगा सर. Yes. तो इसी में डायरेक्ट आएगा सर.
So it will go with high moisture inside the silo.
But it is not a closed silo, sir. ये यार्ड है. They are only section C sections kind of thing. With covered ऊपर से vertical shed जैसे अपना typical exhibition houses के sheds होते हैं ना सर, उस तरह का shed है. It is not a closed silo, sir. Yes, sir.
Properly. No moisture will be, but lot of gap is there actually.
Yes, sir. We will maintain the gap.
Otherwise, there will be a flowability problem. If it goes with very high moisture inside the silos, that actually Bokaro Steel Plant is having such similar kind of operations. They keep all the coal inside the silos.
Yes, sir. They are keeping those kind of silos which are cylindrical and then conical from the bottom. This is not that arrangement, sir. एक बार photograph फिर से दिखा दीजिए.
Sometimes they face similar problem actually.
Okay, sir.
Coal goes inside the silos with high moisture.
सर ये first time कर रहे हैं सर, एक innovation लिया है.
That's why I said it gets stuck inside the silos and that will be a nightmare.
Okay, sir. हाँ सर. सर कॉस्ट, इनिशियल कॉस्ट काफ़ी ज़्यादा है सर, और बाकी ऑपरेट करेंगे तो पता चलेगा. Thanks, Tarun sir.
Sir, I have one question here. So you have indicated that your VM is around 23-24%, as well as your yield is 70-75%. Do you mean that the burning and other losses are within 2%? And how do you manage that?
Yes, burning losses are there basically because we have the CDQ thing. So So because of that 1.25 burning losses is there, yes. So 75, I mean, with the blend VM of 24 to 25, we will be getting roughly around 75. Ideally, we should be getting, but we are getting less than 75. So close to 74, 74.5 for the CDP operation, and for the heat recovery, we are getting roughly 73.
And the second point in your presentation, you have mentioned that you are doing the pilot test and then only you are doing it for the commercial ovens. And what is the difference of the CSR you get between pilot ovens and the commercial?
It depends upon the different, because we have different pilot ovens and also the different OPT units. It varies between, roughly we can see 15 to 17 points in actual plant.
15 to 17 points. Okay, thank you.
Sir, the benefits, key benefits.
So basically what we
Good afternoon.
Good afternoon.
Since my presentation is just after the presentation of Shankar, Tata Steel, and my entire work was done during my career in Tata Steel, so there are a lot of similarity between these two presentations. So next slide, please. Oh, this is. So objective of this presentation, as already said, which is optimize the use of scarce resources, optimize the cost of steel productions, value in use concept, maximize the quality of coke to minimize the coke rate at blast furnace, supporting the efforts minimizing carbon CO2 emissions, and enhancing the life of refractory of coke oven battery fabrics. The last point which I will actually, I have dealt during my last part of the career. Many a times we just select coal just to produce high CSR, good quality of coal, but we never bothered about how it is behaving inside the oven and how it affects the fabrics of the refractories. And at some point of time or other, the management will face that, and then people will say, no, our blend was not properly selected. Coal blending for metallurgical coke making involves combining different types of coals to optimize the coke quality and for blast furnaces. These are all actually talked about by Shankar. This process is very critical because coke gives the structural supports, provides permeability in the blast furnace so that it improves the blast furnace productivity and reducing the carbon rate. Carbon rate reduction means finally we can reduce the coke rates, and which will ultimately impact the environment finally. So this is the process I have structured it, what the earlier presentation was shown. Selection of coal. First of all, we have to select the right type of coal to produce the right type of coke, yet maintain the health of the battery. So first, coal will be selected based on, to some extent, value in use. Many a plant they select coal, but they normally look at the price of the coal. Say if two coals are exactly similar and having different prices, then normally people will go for the lowest price coal. But that is not the all for a steel plant. For an integrated steel plant, it must be selected based on the value of that coal. If that coal contains a very high sulfur, then value goes down, even if it is at a low price, but finally it will be at a higher price for the steel industry. So that value in use concept must be adopted whenever you are trying to compare 2 or 3 different coal of similar natures. Which coal you should select? And some of the input parameters are written here, and most of them, some of them are additives and others are not additive in nature. But if you want to select the blend, looking at the output, select the blend, you have to first know what output you desire. Then I talked about blending and crushing, where AGI I have specially mentioned. This AGI has played a very big role actually in coke making. There are various types of blending process we follow. Normally, or most of the plants they follow, they select the coal, they blend it, then it goes to the crusher. And when crushing, they are crushing the mixed coal. And if all the coal components are having different AGI, some AGI is very high, some AGI is very low, then there will be at the same level, then homogeneity is beyond question. You cannot make a homogeneous blend. So AGI is a component which is very critically analyzed in case of it is a mixed blending and crushing. But if it is a selective crushing, then that is a big strain. Selective crushing means you crush individual coal and then you mix. Then AGI is not a very big issue. Accordingly, you adjust your crusher so that you can crush all at a same level. Then it goes to the process. Then after testing, if you get the desired result, it is okay. Otherwise, type of process you are following. If it is a top charge, you can use slightly higher MMR coal. If it is stamp charge operations, you should control it because higher MMR coal means it will exert higher pressure on the wall and finally it will get damaged. Then some other sufficient conditions, not necessary but that should be sufficient. If sulfur is in some of the presentation I have seen that more than 0.6% would increase the sulfur causing problem in upstream process. Means more sulfur means it will create problem in the upstream, means you have to desulfurize it, which is a cost. So that's why sulfur also to be restricted to that level. Then alkali content. If alkali content is more than 0.2%, that reduces the hot strength of the coke, and that also creates problem in the blast furnace operations. Then silica and alumina ratio also should be controlled within 1.75 to 2.5. So this is kind of matrix for selecting a coal blend. So plot the fluidity curve to see whether coals are compatible. If it is yes, then you check the vitrinite distributions. If it is yes, then they check the rank. If it is more than 1.05, depending upon the process, then it is okay. It is fulfilling all the necessary conditions. Similarly, if you look at the sulfur, alkali, silica, alumina percentage, if it is within the norm, it should be okay. It should not create any problem, and that will be the best possible coal blend for producing good quality of coal.
Is there any way to define the parameter? Because each battery has a different kind of health actually. So how quantify that part and how we can make a recipe of a blend so that battery health is not getting impacted?
One basic point is you must look at the dilatation properties of the particular coal. If one particular coal is having very high dilatation, say 300 and more, then you can use it, but you have to reduce the percentage of that coal so that it gets compensated in the blend. First particular coal is having very high dilatation, like Mozambique. If you use 60% Mozambique coal in the blend, your battery is going to collapse in next 6 months.
So how much we should decide and how much dilatation we should target in the blend? That is my specific question actually. Is there any particular recipe actually?
It is not a target. It is actually target is dependent on the conditions of the battery. If it's a new battery, you can target higher level to get the advantage of high CSR coke. But if your battery is old and weaker, then you should try to reduce the target dilatation. But that can be countered by some other properties, like you increase the say MMR of the blend MMR or blend CSN, you increase by half a point. Just to reduce the dilatation, you cut the one coal which is having high dilatation, but increase other coal which is having higher MMR. So these are a combination approach.
Thank you, sir.
Sir, one more question, sir. This quality of coke is also dependent on the type of mining. The long wall coals behave differently and open cut coals behave differently. example, for Canadian coals, even though they are of low.
So it's a balancing act based on trial and error method. That's why we say pilot oven. You just tweak the blade, do another pilot, and that way you can get the best results. So there is no clear-cut formula that you just do this, you get this.
Thank you, sir.
Sir, Pradeep here from CLRDCS. Actually, I want to know, we are planning to buy PLT, plastic layer thickness. We are planning to buy. Whether it will be helpful for a top charge battery or not, or what should be in the range of the PLT, of the coal blades, plastic layer thickness.
What coal you said?
Sir, plastic layer thickness, sir.
Plastic layer thickness.
Thickness. What equipment we are planning to buy, whether it will be helpful for a top charge battery or not.
What is the plastic layer thickness?
I don't know.
So you
want to buy equipment we want to buy plastic layer thickness to measure the plastic thickness of the plastic layers. Since Tata still have a plastic layer thickness equipment, we have seen over there. So whether it will be helpful for our top charge battery or not, or what should be the range of plastic layer, thickness of the plastic layer for top charge battery, sir, for getting good quality of course.
It should be around 14-15 millimeter.
15 mm.
Beyond that, top charge actually there is a scope for it.
Next paper is I call Mr. Shishani and team.
Jindal Steel, actually we are operating on the blend philosophy as far as the coking coals are concerned. Nowadays there is a big challenge, as our conference is all about opportunities and challenges. So basically nowadays you face a big challenge as far as the availability of the prime hard coals is concerned. So there is one of the things is the scarcity of the available prime hard coals in the market. Again, there is a cost involved as far as prime hard coals are concerned. So basically, our paper what about is using of the LVHR coals, that is high reflectance, low volatile metal coals, into the coke making of stem charge batteries, because obviously the top charge batteries also have used in the past to a level of small percentage in the blends, but we have introduced the low volatile high MMR coals into the stem charge batteries as well, and we are operating up to a range of around 20%. We have gone up to 25% as such, but we are operating in the range of 15 to 20%. So basically the PHCC scarcity and volatility in the market and import are motivating reasons. We have gone through this, and finally we have taken the pilot trials as far as some batch through some batch process, charging some 15 ohms, 20 ohms. They play a major role, and obviously the hard or prime hard coals play a major role as far as quality is concerned. But as far as health and other things of performance or blast furnace productivity, basically directly relating to the permeability of the blast furnace, can always have an impact. So ultimately you need to have some stringent control. So you can start with lower percentage of the LVHR coal in the blend, and substantially you can go on increasing as per depending on blending. You cannot have heavy blending. Basically the stringent control of the blending and process parameters is important. Again, the limited LVHR domestic availability here, but you can have these coals from international market, slightly cheaper than the prime hard coals. High MMR or LVHR coal as far as the Indian market is concerned, Indian domestic supply is concerned. But the basic problem here is the supplies of the Indian coals, and again the viability, basically because what BCCL is looking for operating model, the modus of operandi and operating the washery and selling of the middlings and all other things, that is creating a lot of issues as far as going into.
Manish, to answer your question, LVHR coal is marketed by GSPL only, and
to replace the PCI coal. PCI you are using it to increase the inert in the coal, so that the coke strength increases. That is not to be replaced with here. And cost per PCI is also not cheap.
Nowadays PCI is
good. It is higher than semi-soft coal or near to hard coal even.
Nowadays, rather the soft coking coals are almost at the similar prices, and you can have some coals which are at the lower prices than the PCI coals.
The tallest coke oven battery being commissioned in India, 6.78. That is that has added another feather in their cave.
Thank you. Thank you.
The PPT mainly consists the blending according to the quality and the performance and the cost of the blending. That we consider in the blending at the time of blending. If the as fusion temperature will go lower down to 1350 or 14 degrees centigrade, it will fuse inside the oven, which will form some clinker on the oven walls. We maintain is approx 1.1 to 1.15, and the V9 content of the whole blend is approx 65 to 70%, and the V9 to V14 approx 75 to 80%. And the blending optimization, earlier we have used approx 30% of PLV.
To save prime coking coals by making use of semi and lean coking coals, Japan led the way by inventing partial bracketing of coal char. It was a project. Primarily, it was envisaged to supply 1,000 tons of coal briquettes. A wide spectrum of varieties of coals, coking coal to non-coking coal can be used, with the promise of enhancement of coke strength, M10 particularly. The notable feature is it can be retrofitted into any existing coking plant. Though initially there was some resistance from the workforce since the cleaning has to be enhanced. But later on, when we found out the solution, the problem could be solved.
In terms of, because I got a phone call from Tokyo, since Japanese, they wanted to inquire how this plant is performing. The Japanese forgot everything, and they want to reinvent perhaps. So he has done an extremely good research work. And let me tell you the audience, 1970s, 80s were the starting phase of Indian metallurgical coke industry. Everybody was struggling. Tata Steel was struggling with stamp charging. Not very successful, lot of failure, lot of difficulties. All steel plants, no imported coal, only with the indigenous coal, and it goes on. Very good job.
No, sir.
R.K. Sabat, all executive members of SteelTech, and all distinguished members of the coke oven industry. I am Connie Zhang, the representative from China Shougang. It is my great honor to meet you in this manner. I would like to grasp this opportunity to introduce you the innovations and achievements Currently, our market share for automotive sheets, electric steel, and thin chrome-plated sheets remains in the top 3 domestically. In green, Shogun also leads the industry. We designed and applied digital twin technology, achieving a non-intervention rate of over 95%. The beam technology utilized on the 300,000 ton per day seawater desalination project won the China Outstanding Project Award at the 2000. The world's first facility to biological synthesize ethanol from industry off-gas containing carbon dioxide. Large charging vehicles for battery electric cars. Initiate a project to produce a high-quality steel with near-zero carbon emissions. In the 100 megawatt gas-fired power generation unit optimization, we achieved an estimated annual energy saving of 93,000 tons of standard coal equivalent. At Shogun Tian'an Steel Company, the 1,580 blending station implemented a production model using a blend of coke oven gas and mixed gas for. Backed by a strong in-house design team and decades of operational experience, we have undertaken full process projects covering raw material handling, sintering, pelletizing, coking, blast furnaces, steelmaking, and iron mills in Southeast Asia, Africa, and the Middle East.
Blast furnaces, Shogun is the inventor of Chinese PCI technology, barrelless top, and BF high efficiency and long.
To our body because it's so small that we inhale it, it goes directly into our lungs, bypassing all the natural defense systems humans have. And it's not only the health issue and taking them back to the process. This is of course what we would like to see, this is what we would like to breathe and which we would like our families to be able to breathe. Our company's target is that we provide new technology in the area.
A screen house in a coking plant in SSAP Rahe, coke arriving from the reddish conveyor to the screen house, and it was suffering. There were lots of dust emissions. They had the existing back filter system operating. The back filter system can be seen on the picture on the background of the screen house. But anyway, the situation was that the capacity of the back filter system was not sufficient to contain and maintain the air and the dusting of this facility. And it was causing a stress for the filter, for the back filter. The lifetime of the back filters were reduced only to even to 6 months. And they were actually having considerations, actually implementing and investing a completely new back filter system. It's based on the flow dynamics, and what it does, that it forms the shape of the flow in such manner that the dust can be separated out of the main flow and the clean.
Mitä raaka-aineesta irtoaa, ja nyt tässä on tämmöinen tehostettu keräys tuolla meidän annostelussa, jossa yritetään saada paremmin näitä eri pölyjakkeita talteen. Nyt kun on testailtu tätä laitetta täällä Filtropetin kanssa, niin nyt huomattu myös, että minkälaisia määriä pölyä tulee erilaisista noista meidän raaka-aineista, niin tässä ehkä on tullut myös semmoinen ajatus, että näitä pölyjä kannattaisi kerätä erikseen ennen kuin sekoittaa keskenään, niin se jatkojalostus olisi sitten paljon helpompaa. Outokummulla meillähän kierrätysaste muuttuu.
It enables the material recovery, having a discrete system on the very side you can
so we can maintain it as long as it's needed.
And what's the downtime are we looking at? Say in a month, what's the downtime?
It just, we sequence it with the shutdowns as required at the operations. So we don't need that.
Depending on the materials, we have, for example, the pipe ranges. For example, anything that there are no layering on the silos, etc. So we have very good experience on, for example, handling limestone dust, which typically is not the easiest material.
Type of dust or raw material as required and different conditions.
Thank you very much. We need to.
Thank you very much.
Special thanks to them and big round of applause. They came all the way from
Thank you very much. Our next
India, home of the iron pillar of Ashoka, 98% pure iron, 1% phosphorus, interesting, but again very low sulfur. So in India, sulfur was still a problem. So I needed to understand sulfur better in order to market our coal. Sulfur is not considered a positive element in steel. A few to 0.005 and some specialist grades to very low levels. But global targets for coke sulfur seem to vary quite substantially. The table below is from a book that was published originally in the Netherlands. But US targets are understood to be 0.8 to 0.9. And the US generally has high sulfur coals as well. Chinese and US coals can range, some I've seen, up to sort of 2 to 3% sulfur being used. And Nippon Steel have used pet coke in blends, and it's interesting some people here are using pet coke too. And that can be very high, up to 6%. So considering we have just extraordinary fluidity, 130,000 ddpm and more than 300% dilatation, absolutely extraordinary. There's a lot of discussion here about modelling, predictive modelling, and it's interesting to see. It seems to be gaining a lot of ground around the world these days. So we have quite a low ash semi-hard. It's about 3.7 ash, late 50 CSR. So I'm not seeing that from the organic side.
Thank you. Fuel which is going with sulfur dioxide or some sulfur component, sometimes we face that there are acid rains in the vicinity of coke plants. The gas which is coming out of the chimney, and if humidity is high in the atmosphere, it falls down in the ground and that becomes acidic. And we have experienced it in time and again.
Yeah.
So how to resolve that problem?
So I guess the acid dew point is a discussion of whether you're going to condense it within the flues and pipeline. If you emit it to the atmosphere, then if your airflow is blowing most of the stuff out to sea, it doesn't really matter so much. If it's taking it on land, you could have a problem. That would be something that would have to be investigated. Yeah, I haven't done that.
Okay, thank you. And you have said that better than Australian coal. It is almost half the ash of Australian coal. So what is the overall benefit? You can do some calculations.
Yeah, you can calculate that out depending on your blend cost, what your blend ratio is. Well, usually for that low ash one, and if you of ownership, what ArcelorMittal used to call the total cost of ownership. So that's how much are you paying for it, what's your freight, and what's your value in use. And you add those all together, is it positive or negative? And generally, if I model that versus Russian coals and all sorts of others, I believe we can come out positive on that particular coal. If you don't come out positive, the next thing you have to adjust is your price, of course. Otherwise, what are you offering?
Okay, thank you.
Yeah.
With Rob's permission, can I add to the answer to the question of Haldar sir? One is that the chimney fall acid rain you are talking about, the gas after the coke oven, it goes to the byproduct where the ammonia and sulfur recovery happens. extensively used this coal during my previous stay at the Jindal, and I have checked that the change in the as and the incremental increase of the CSR and the strength hot strength.
And that's true. That's why I said overall economics of using it.
So the incremental, the blend cost gives the offset in the hot metal cost. That has been extensively used. I think, we have never shared that information to them even. It was in a patent for us in the Jindal days, so it is in our. Anyway, thank you, Mr. Rao.
Thank you.
Thank you. Very insightful sweetener to reduce the hot coffee.
Thank you.
Thank you.
Good afternoon all. Myself Shivkumar Mane, with me our SB head Mr. M.G. Nagaraj and Srikant Patil is also here. Yeah, it's about our business is pig iron, casting, steel, seamless tubes, and we are from K Group, the Kirloskar Group company, one of the. See, our companies are Kirloskar Oil Engines, Kirloskar Ferrous, and to final product machining. See, from iron ore to pig iron to alloy steel and tube, also from pig iron to foundry castings, to machine castings. So we are talking about the challenge what we are facing during the cocoa one. While designing this cocoa one, we also spoke about the power is equally important. So the technology we adopted initially from the ISJEC and originally from Chinese. Then later in the phase 2, we worked with the Thermax. About the energy gap, loss is significant heat transmission losses. I am quickly covering because I was told to complete in 10 minutes. So it's about the advantage. Let's talk about the advantage. What has happened? We need to capture the high temperature. So those challenges were mitigated during the design stage. We can see the proximity of the oven. The boilers are just in between the ovens. Let us get into the technicality. We all know it reduces we need not to depend on the fossil fuels, and energy efficiency also we can met with the waste recovery boilers. And to summarize what we are trying to say in KFL, what we have done is we are the first to place the boiler in between the ovens in India. Then we, of course, we maximized heat capture, which is at 1200 degrees centigrade. And of course, we increased the. Thank you. There are no questions, I can. The boiler inlet we spoke about 1200, whereas at the sole temperature we are talking between 1320.
Requirement for producing 1 megawatt?
During the phase 1 we were at 3.95. With the second setup with the Siemens turbine we went up to 3.85.
What is the distance between, you have modified duct from oven to the boiler inlet?
Now you know that there will be a T-joint duct,
yes,
which is away from the quenching car, right? Yeah. But here we instead of placing the duct away from the oven, quenching side, we just placed in between straight away in between the ovens. We just sandwiched the boiler.
Current gas volume?
Volume?
Yes, gas volume.
Yeah, we have 4 boilers for the 2 turbines, 2 machines. So each boiler will draw 75,000 nm the optimum operation.
How many ovens is required for one boiler?
Pardon? You are talking about CPD?
CPD, I am talking about how much ovens is considered with one boiler.
Yeah, it's 22 ovens.
22 ovens.
Yeah.
And what is the draft at the ID fan catered by?
At the ID fan it is high velocity as usual, -220 mmWc. Okay. And at the boiler inlet we are at -25 to -30.
Okay. Thank you.
Thank you.
Burning points in your batteries?
No, let me answer this question. See, excuse me, I'm here. The localized burning will not take place because it is under motion of 250 Pascal of draft. So there is no question of localized burning.
No.
And 350 is soul temperature also, and 350 is combustion chamber also.
In turning
In the turning also no. The design is made for that, such that it is a 6 link rather than 4 link. So at the two places diagonally there is a suction. So there is no question of localized.
From where you are providing the air for this heat recovery ovens?
Heat recovery ovens, air is provided in the two places. One is primary from the wall top, and which is the secondary in the 6 link.
Yes.
So these two are to be controlled, and that is the only control for this kind of disk.
And the overall draft for the battery is?
See, there is two types of drafts again. One is on the wall top in the main primary, and there is another secondary. We maintain around 40 pascals, 4 mmWc in the wall top, and here also 4 mmWc or 40 pascals.
For individual ovens?
Individual ovens.
And that will be keeping on regulating depending upon the cooking period?
Yes. It will be depending on, first initially it will be 4. And then as the time goes, if your cooking cycle is 63 hours, at the end of the 63 hours, primary will be closed and secondary will be closed.
One more question apart from this. What is your burning loss in your non-recovery?
This is very burning question. So, I don't know how can I tell this burning question burning answer. Burning loss standard as per our horizontal oven system is 3% burning loss. But we are getting much below.
Similar, please. This is especially we want to send it for the yeah, that is our special gift from India hosting. Thank you, sir.
Its process, how we are controlling the temperature, the draft which is required for the cooking process, and broad comparison with the vertical, what is the difference between the vertical and horizontal coke ovens, and the constraints which we are facing currently in our production of coke. 4 meter, and the width of the ovens is 550 mm, and the very same is also in the recovery ovens. The door sealing is also very similar, which is a flash plate and door frames are there in the doors, and the anchorage of the battery are same continued with the CTR, BTR and the LTR of the ovens. These ovens are then regulated by the primary holes which is present in the top of the heating valves. In the recovery ovens, it is known to us, the heating valves in the top are covered by the flue caps, And in this design, the heating walls are also present there and with the similar design. But it is shifted to the main tunnel, and then the flue gas is sent to the WHRV for the steam generation. For the perfect heating of the and maintenance of the temperature of the ovens, the amount of air which is required is controlled by the vertical
topic. So why the design is unique? It is having three unique features. First is the burning loss. We are getting 1% burning loss. Okay. So if we see the conventional coke oven, heat recovery coke oven, there are burning loss 2.5%. So we are saving 1% of the coal. Second is it is environment friendly because all the systems runs under negative pressure. So if you will see the battery, it is resemble to the byproduct recovery type of oven, but it runs under negative pressure. So pollution is very less. And the third point is the cost. So beauty of the oven is we are able to get 67 CSR at the blend level fluidity 200 ddpm. So see, if we will compare with the recovery type of oven, their blend fluidity minimum 400 to 500. So we are saving richer coal over there. So these are the three beauty of the design, and in line with the PPT. This is the diagram of our vertical non-recovery coke oven. From their top, we are supplying air. So by supplying air and fuel as a VM, it ignites and it gives heating to the oven itself. So that's how the vertical non-recovery byproduct. So it is less complex. As it is run in negative suction, so emission is very less. So coming to the burning loss context, we require 1.3 ton of coal to produce 1 ton of coal. So a specific is
yes.
Thank you, Mr. Manish. Thank you, Mr. Manish.
Yeah, Manish,
In fact, the author of the presentation is not available, so we may not take questions. Or
waste heat flow is underground, right? Underground.
Yeah,
right?
It is underground.
Then how do you manage if the underground refractory get damaged?
Yeah.
Then your heat loss will be more, and it cannot be repaired, and neither it can be seen. That can be seen. So, do you think it's a challenge for this?
Yes, it was a challenge for us, as we have done the modified engineering. So what we have did.
No, it is 100% eliminated by doing whatever you have done.
First of all, I will explain what we have done. It is not 100%, but somehow we are trying to manage it.
Yeah.
So
that's all. I think, Manish. That is what I wanted to know.
Yeah.
Another thing is your damper, which is allowing or controlling your waste heat to go into the damper, underground waste heat. Yeah. If they break and fall, is it happening?
Nowadays not happening because we have gone for the water-cooled dampers with the LC castable. So LC having giving us more sustainability in terms of refractory life. So nowadays we are not facing that problem. But if we will face, we are not facing it nowadays.
The circulating water is protecting it from the thermal shock, which is hit or strike it over for the new damper.
Yes, but the damaged damper will permanently go below. It cannot be removed.
Not that right.
No?
It is hanged with the chain blocks. Manual hanging is there.
Okay, okay. Thank you.
Will be more because it is horizontal. What is the density of what you can reach?
1.14 we are getting, bulk density we are 1.14.
Is it wet or dry? Is it wet or dry?
It is at 10% moisture.
It is wet.
Moisture.
Yeah.
So it's wet. Yeah, we are talking about it. So 1.15 you are achieving.
This is very good.
Yeah.
I guess this is not real stamping, yeah? What I know
We are having
is
hammer stamping. No, it's hammer stamping, not hydraulic stamping. That's why we are getting that value.
As this is a vertical design, we are the stamping hammers and similar to the recovery ovens stamp charged.
With hammer and cam arrangement.
Actually, the one of the advantage of the heat recovery, normal horizontal heat recovery, is longer CT, allowing it to give you a bigger coke size. So probably are we losing something on that? Maybe we are gaining something on the lesser burning loss, but in terms of BF plus nut coke, which is important to the blast furnace.
Yeah, right. You will get, we will get same size like byproduct type of oven. So we are having slot ovens. So maximum size is 200 mm maximum. So no lumpy size is there. So if you will consider nut generation, it is around 1.5% and fine generation below 4%.
That's very good number.
That is another beauty of this oven.
But one of the limitation which you mentioned probably is that you cannot use high rank coal, which is one of the major advantage of horizontal heat recovery ovens.
Yeah.
Thank you.
I think I can aid you, Manish. Your observation is correct. The MPS of the coke in vertical type compared to the horizontal type non-recovery. So if you are comparing with the Hooghly met coke, the vertical type MPS of the coke will go down.
So that is why my point was, if the BF plus nut coke yield is going down, and maybe you are getting some benefit on the burning loss, we have to see whether it's compensated, which is good actually.
The nut coke can be put on the periphery.
Nut coke there is a limitation because whoever from the blast furnace we know that, but with a lower coke rate, it is very difficult to increase the nut coke consumption actually.
Come to Angul JSPL will show you no nut coke is generated at all for outside market.
That's a great actually. Thank you.
Thank you, sir.
Aerated pitch, but that is already in the magazine. But one more presentation by Abitak. That person is not available to present here. So I will use that slot for introducing two new persons here. The first one is drone system, IT-based system, which has sought entry into the steel industry to make steel operations more flexible and more efficient. And this is the snapshot of the company. The company name is Indrone Aero Systems. It was incorporated in the year 2006. Accuracy does not really meet stipulated 1:1000 specification. The low resolution makes more difficult to recognize septal and boundaries, and 50 centimeter satellite image. So they prefer to use UAV for all their stockade measurements. So this type of drones are nowadays used in many of the coal stockpiles and cement industries. And I understand that Kalimganagar plant also, the Tata Steel has started using this kind of drones for aerial mapping of 23 of their locations. And this is the operation features. This is a clear boundary demarcation and clarity of images and boundary from 0.4 to 2 inches per pixel. And the measurement accuracy is 95 to 99% with very high grade image resolution, and it's easily accessible. And advantages: higher resolution of capture, finer spatial monitoring, not affected by cloudy weather, real-time monitoring, post-processing is quicker, cost-effective than satellite and aircraft. So this I had experienced myself just before my retirement. In the year 2019, just prior to 1 month of my retirement, I had called this group for a demonstration in Beneficiation plant. So after successful checking of all the points and demonstration, our safety monitoring while working heights. So this is the contact thing. So this presentation will be available for all with contacts. And coming to the next.
Mr. Subramanian, I'll try my best not to put you to sleep. So what we are is basically, like Mr. Subramanian said, an intelligent document processing platform built for enterprises. The challenges today in an organization, number one, is that there's a lot of inefficiency in terms of search efficiency and things like that, where employees spend hours searching for data which may be trapped in silos and somebody else's system in a different country, for example. And again, data sovereignty, and what I mean by this is the moment you upload your data to a traditional AI platform, let's say you upload it to a Perplexity or a ChatGPT, etc., it goes and sits on third-party servers which you have no control over. And this is a huge problem which basically leads to organizations these days trying to create their own GPTs and their own solutions in-house. So what we've done is we've essentially simplified the process for uploading documents and getting answers from documents using a retrieval augmented generation method, which is known as RAG in the AI world. Like Mr. Subramanian said, the IDP is a central intelligence repository wherein all of your company's critical information, be it your R&D documents, be it your user manuals, financial guides, whatever information you have that you don't want essentially to sit on a third-party server, you can upload it. Our platform breaks it down to something called natural language processing. And once that's done, you'll be able to query and search for answers from the IDP platform. So what we've done is, I won't bore you with the technical elements because I know that. Essentially what we do is we let you upload a single English language instruction. So the instruction may be something as simple as act as an expert in analyzing and improving coke strength and composition. So that English language instruction will go into our system as a prompt information, a system instruction, and a context. So if you look at these three things, they will essentially act as an expert on your behalf to be able to extract data from the document that ideally someone who's not as experienced in the field may not have been able to extract because they don't ask the relevant answers or they don't ask for the relevant context from the documents that are being uploaded. So this is what the Prompt Studio does. And then of course, once this is created, you essentially, you assign users, upload your documents, create prompts, and you can ask for questions and you can query from those set of documents. So just to give you an example here, I have asked the system a few questions. So one of the questions is, how can I improve coke strength by boron spray? So this has given me a citation saying from the 50 documents that you've uploaded, this is the exact document that you have asked me for. So it gives you references, it tells you which document it's picking up what answers from, and it will give you those exact answers saying that, this is how you can improve it, these are the experiments used in the process of testing the paper, or whatever else may be of importance, to actually get information from. And of course, it gives you a confidence score, which basically means that if it's telling me that it's picked up an answer from page number 7, and if the confidence score is 0.95, it means that it's 95% confident of the answer. So,
how do you check the information which is extracting from the different literatures? How do you very much confident it is extracting the right information?
So it gives you a relevance score if you go back to it, right? Okay. So let's say that it comes out with a document and it says this is the document being cited. It tells you which page it's picking up the answers from, number one, and it also tells you how confident it is. So if there's a confidence score of 0.95, that means it's 95% confident that it's from page 7 or page 8 of the document that's being referenced.
That 5% may be wrong.
The 5% is, that's the algorithm that's picking up and giving you an answer, but again, it gives you the page, so you can cross-reference with it. So it gives you the page, so if you click on the relevance score, it will tell you that it'll highlight the text feedback loop built in, so you can tell the system it's not a right answer, you can give it the right answer. It'll learn the next time, so next time you ask for a question, it gives you a correct answer.
Any possibility also that it can extract literature also from the different sites? Or all the time we need to give that literature?
No, so like I said, we are a platform built for enterprises. So as an enterprise, you would have the responsibility of uploading your content onto our platform and get the answers from whatever you want to search for.
Any trial person also?
Sorry?
Any trial person also?
I can give you a demo, and I'm happy to work with it. Thanks.
Me, Deepangar Banerjee, and our technical consultant, Mr. Paolo Litno. This is a very large presentation. I will compress it to the 10-minute slot which have been given. I will only go to the critical aspects of the presentation. This will tell you the life of batteries in various countries around the world. You know, in countries like US, they're running batteries more than 50 years. And if you go to Korea, there are also long life batteries are operating. Unfortunately, India, the life hovers around optimization and become more independent, Indian coal dependent. But there is one more aspect to be also viewed concurrently with that, as Mr. Haldar said this morning. Yes, coal plant optimization is one thing we must aim at, but what happens to the battery? That is also a very important thing to consider in the background. Fosbel has been working for more than 40 years with our customers around the globe in helping them understand the effect of various parameters, including coal plant, and the various coke operation parameters to optimize the battery life. There in the top row, where we have a heating module, a pushing force module, battery expansion module, the door repair module. So we can drill into this common system in depth. And if we talk about common system itself, it will take about a couple of hours at least to give you the features of this common system, which helps you to monitor your battery health and performance. Due to shortage of time, I will simply not go through the details. I will only go straight away to what is called as the output from comet. Comet is a refractory condition. So here you can see the entire battery, both ram side and the coke side. These are some of the outputs there. And this is a pushing force report. Like our inspectors are there in the plant day in, day out. There are certain other companies in the world which do the battery diagnostics, but these are all usually annual diagnostics. Nippon Steel does it, ArcelorMittal does it. They're all annual diagnostic systems. But our system is day-to-day, dynamic on the field, which gives you a sort of better control of your parameters and give output. This pushing force gives you day versus pushing force moving. So once you know that there are some activities required to be done to take the curve, real curve, close to the theoretical curve, you can easily understand whether you are going towards the theoretical life expectation or you are going to end the battery life shorter than what you expect. So this tool is a very useful tool for the customer to keep a track of day-to-day basis what is battery heading to, whether it is going to touch 40 years or it is going to fail before. So here are some more examples of the battery which was not behaving well in the beginning. By taking some steps, the ranking has come down. You can see the slope of the curve is changing. Ideally, this should start from the beginning of the battery when it starts operating. But usually the customers call us after 10 years or 5 years or 15 years. By the time the trauma has already happened in the battery, we cannot reverse that. We can only do certain more work to bring the ranking down as much as possible so that we get closer to the theoretical curve to help you achieve the exponential life of 40 years or even more, depending on your objective. So this is also news. This summarizes the various technologies available, like starting from ceramic welding. We have a process called liquid dusting. You might have dusting in ovens to seal the micro cracks. When you throw a powder into the oven chamber, pressurize it, it sucks into the cracks, micro cracks, and seals the cracks so that the leakage is reduced. We have come up with a liquid dusting, which is more effective than the powder dusting. Firstly, from the point of view of that, it is atomized medium, which goes into the cracks much more effectively and seals the gaps much more efficiently than the powder system. Then you have this gunning, which is used still, and we have a different gunning system there with fused silica compared to normal silica gunning. This technology is now catching importance and popularity around the world. The beauty is, if you build a new wall, it may take 3 months, 3 months or more. If you take this big block, you can do it in a couple of weeks. You can imagine the amount of coke saving that you will do, the time reduced, and the number of blocks are less, so you can build a wall with 7 shapes instead of having 450 shapes of bricks and trying to build the wall. So this technology is gaining popularity. That when the cost element becomes manageable, this will gain importance. I am probably going to not go into much details about the comet system now. I have talked about the salient features of that. This is one of the well-maintained batteries. When you put all the practices in oak and then maintain the battery. So to end with, we are here to help our to convert the data which you are entering into the prediction report prediction.
So whatever existing instruments like temperature elements or the draft, those are all going to help you.
Yeah, that's
like
right.
it's a thermal. You said it's a day-to-day process.
Yeah.
Thermal imaging will be done.
Yes, we measure the cross walls on a periodic basis and get the cross wall temperatures fed into the common system. Once you have the battery standard limits fed into the system, like what is your battery aim temperature, what is the standard deviation you want to aim at, this tells you how far you are from the battery aim or the standard deviation. You can also tell you the flues in which you are having problems. So you can zero down on those flues and take corrective actions.
Yeah, it's about nothing to add new instruments into that in the comment.
Yeah, we have parameter and the algorithm software will be
within the available. It's all. Yeah. Thank you, sir.
With all data, and hopefully all these are related to gas recovery cocoons. Do you have similar data related to heat recovery?
Yeah, that's a good question. This common system can be implemented in both heat recovery as well as non-recovery ovens. Any design of battery, whether it is an auto design or a Gyprocock design, you can apply this to all designs of the battery.
Yeah, it is understood. My question is that, do you have ever done it is in the heat recovery cocoons and yes, how it looks like?
We have done some work in Haldia and we given some reports to them and also JSPL Raigad. Yes, I can share with you some of the copies of reports for heat recovery batteries.
Okay, thank you.
Thank you.
Yeah. Thank you so much. Thank you, sir. Thank you.
Thank you so much, Mr. Gawat, for that. So, our company is based in Germany and we are specialists for co-working machines. That they want to help productivity. Yeah, so they are asking for by their own R&D and asking for the technology to be designed to be supplied. But actual, what is happening in the market is that they are giving only just the space and saying what is the production rate, what they want to reach, what is the cycle time, and what will be the cooking time and everything. Yeah, so actually the effort is changing. So they are expecting, when we can see the picture on the top, that you can see that there was a lot of fume, a lot of smokes in the past. Kilometers far away, you can already smell that there will be a past. So, and even if the smell will not happen because of there are not fume, there are not so much dust. Yeah. So that's why we are always saying we need to comply the environmental regulations and we need to increase also customers' image. So how we can reach these kind of things? We can do it as like manless operation. Yeah. So that means there will be no human failure and there will be well coordinated between the machines and second level, means battery coordination. So, and of course also important is personal and machine protection. To work manless operation means you need to find a surrounding fence. We need to install some sensors that if somebody is entering during the operation of the machines, that the machine is getting stopped. So almost around of the world, when I'm looking back in Korea, in China, and in Japan, they are always working manless. But actual Indian customer is not using manless operation. So we can have well communication, interlockings between of the machines, and we can get also contact with a main control room that we are getting batteries and all the machines what is working, and it can be communicated all tools by Wi-Fi or radio data to to main control room, and they can only just observe. If something happens, of course, they can interrupt the process. But normally, when everything is working, then it is not needed to have an interruption. Our main aim is that it should be not get stopped by the production. Yeah? So process automation and visualization at level 1 and 2, as I explained beforehand, doing proper way maintenance. That means it will get stopped somehow. Yeah? So that's why maintenance is important. But when you see the picture here, the maintenance almost is done by humans. So this is dangerous area. This is because of heat, because of gas, because of pollution. So all those things can be avoided once we are putting some mechanism on the car. So once that the people was maintaining on the front of the battery, the pusher then run out, and they have pushed one of maintenance team inside of the oven. I've heard this. So then we are having also on top such kind of cleaner, what is automatically moving. Once the car is moving, then we are having all the collection, spillage and coke collecting plants on both sides, and we are having also veg cleaner. So all those can be implemented, and on the left, right.
Madam, any questions, please? Both from
Done a decade. Is there any progress? How do you want to measure the weight of the coal cake before pushing it into the oven?
Yeah, actually, we are measuring the density. And once we are measuring the density, we know, and on the base of coal cake size means coal stamping unit, then we know, and even of course, height also is important. Yeah, full dimensions we are measuring. And once we are measuring these dimensions, and in the combination of coal cake density, we can recalculate what is the inside of coal box. Automatically that you will get a curve. Yes.
That will solve many problems.
Yes. Because once you are putting one time maybe lesser coal, at one time you are putting more coal, but the heating of the battery is still same, yeah? Then you will get maybe more burnt coke out, yes.
And density is automatically measured?
Yeah, density we can measure automatically.
You can measure?
Yes.
That has been implemented somewhere?
Not yet. I guess we have to combine it with how many volume you are filling in. And of course also with combination of density, it's much important to get the real good coke quality, yes. So.
The present generation coke makers are aware of the systems which you have beautifully narrated. The ultimate nightmarish experience we all ever had was the round pushing caused due to misalignment of coke pusher, door extraction, quenching car. Of course, there are a lot of systems which have been developed now. So, what Hude has in store for such kind of situations?
See, normally, we are making coordination systems always. Once we are going in the manless operation, so that means the coordination is the important thing, right? So once we are opening the door and going in with our pusher end inside of the oven, of course the other car must be there and open the door. Yeah. So, and even we are controlling by our system. Once pusher end is going in, then we are also having this kind of curves. What kind of forces are going in the motor of pusher end? So there also we put it on the other side that there will be a transfector, of course, yeah, and also quenching car below down. So all those interfaces can be checked by, and we are getting the feedback of the cars. You know, the SCPM is the master car. So SCPM is getting all those informations from other cars and giving also signals that you should be ready. Otherwise, the car will not push.
Got your point. Thank you, madam.
Thank you, ma'am. May I request Dr. Devchand?
Thank you.
30% of the sensible heat, and it's a big source of energy which is going to waste. So basically at our plant it is 120 into 2, the two different CDQ plants, wherein we take our coke after pushing at almost 10-50 degrees centigrade, which is going to the CDQ systems, and it is the waste heat is recovered into converting the water into steam through the waste heat recovery boilers, and we are producing almost 100 kgs in process network basically. So basically what is the difference between CDQ and wet quenching is comparison. The energy recovery heat is largely wasted as far as wet quenching system is concerned. So that 80-85% of heat you can convert it to produce steam for the process usage or electricity or driving any other kind of turbo compressors or something. Environment impact, high emission of dust, and then going to the steady ramp up for the wet commissioning of the system and going to the maximum quenching your system. So through the inert gas circulation, so minimum of the thermal shocks and minimum wear to the this thing. So coke breakage is less, and getting down the temperature to around 150 degrees basically, but it is almost below 200 degrees all the time. So it is ranging from 150 to 170 degrees. Basically, where the process of CDQ is concerned is basically when you charge the coke, there is a system which is with the circulation gas. So you need to ensure all the time the oxygen level, hydrogen level and carbon monoxide level into the system to 1, 3 and 6% so as to avoid any kind of process safety incidents. So basically, this is the recovery of the sensible heat from coke. So almost we are operating 2 units right now with 120, and we are coming up with the third unit, which is 260 tons per hour for the latest coke ones. And we are producing right now almost around 120 to 140 tons of steam, superheated steam, which is going to the turbo compressor of oxygen plant and hot blast blower for the blast furnace and process network. Environmental benefits, going through the again saving water, again saving the reduction on the CO2 emission and SO2 emission, and again the particulate matter, that is almost the fines which is going through the wet quenching, that can be reduced because CDQ becoming a confined type of system. This is the impact on the coke quality. So as per our experiences now, we are almost having increment of the CSR and M40 almost at 1.5 to 2% and moisture of around 0.6, which is discharged from the CDQ chamber. Challenges, obviously the skilled manpower and process integration and control of the process parameters so as to ensure the process safety. Basically, CDQ, you can have, this is a very strategic decision to have, even I can say that non-recovery plants which are always working, it can give you more steam than the waste heat recovery which is going through the gas. So that is not at all working anywhere in the non-recovery, but we can consider this CDQ for non-recovery systems as well. Basically because you can have lot of steam basically on the cost saving part as well, and But the only thing is, with the CDQ process, you need to go with proper process safety arrangements so as to not to have any process safety incidents. And detailed feasibility and techno-economical studies based on the plant specifications and the total configuration, almost 240 or 250 tons per hour basically. That is almost 5,000 tons a day. So one unit is catering to 2 batteries, which is around 2,500 tons a day.
Fine. Oh, it's a recovery oven.
Recovery oven.
And it can be applicable to non-recovery also.
It can be applicable to anything provided the retrofitting of the system, because you need to take the coke into the CDQ buckets inside of the...
There is a travel time losses.
This is elevation and other things.
But there will be heat losses between travel time.
Everywhere there are that level of heat losses will be there in any system, may it be recovery or non-recovery.
The bucket is more compact. The bucket is more compact, so the heat loss is less. That's the advantage.
Hi. We are operating at 68 plus CSR and CRI of 23 to 24%, up to 22.5%, and MICOM values of 88 to 89%, and M10 of around 5%, below 5% rather.
No, what is your change? Which
change is almost the same values we were maintaining with the wet quenching also, but the difference is the linear blend. So now also we are maintaining the same properties with a slightly leaner blend compared to the previous blend. So you can have a yes, CSR and M40 almost 1.5.
Any change in MPS?
MPS, there is no change as such. Almost similar MPS you will find, maybe slight change in the MPS.
I've seen papers saying that particle size is reduced slightly, but it's only the big pieces, so you have more in the optimal range for the blast furnace. Have you got any comments on that? So the mean coke size reduces when you go to CDQ, but it's only the big chunks and they then go into the optimal particle range for the blast furnace. Have you seen anything similar to that, like a general particle size reduction?
The particle size, there's not much impact on the particle size. Very less impact on the particle size.
Sir, this is Sri. So, how much burning loss we can consider in that, sir? 1%?
Yes.
For CDQ?
Less than 1%, maybe around 0.4, 0.5%.
0.4%. In battery, 1%. Total 1.4%.
No, almost similar to the wet quenching as well as dry quenching, not much difference.
Okay, sir. Thank you, sir.
So the cost which you are gaining by producing the steam is getting offset by the money you are spending to treat the water. The only benefit, the net benefit you get is less moisture going to blast furnace, because here the moisture goes to blast furnaces roughly 3 to 4%, and in CDQ you are almost less than 1%, but typically because the dust generation is so high that many a times we have to add some moisture so that my bed goes dust free. So the advantage is only mainly at the blast furnace. CDQ in coke oven, the expense is same.
The other benefit is obviously you can save on blend, blend, and the other benefit is blast furnace operational.
That's what I said, blast furnace.
Because before CDQ, I would like to share one more thing. Before CDQ, we were not able to go above 9,000. And the day CDQ came in, we are consistently producing more than 11,000 to 11,500.
That is basically 3% moisture, less moisture.
4% moisture.
Yeah, that is what.
Yes.
That's what. That is the biggest advantage. But by product side, it has become a huge challenge to treat the water.
That can be catered through the other way, because this water is not going to quenching, so that water is going to slag granulation plant and other SMS slag treatment. So
But these days they are challenging that also. Okay, thanks.
Yes, thank you.
Thank you. Company is Tata Steel again, and we are talking about so many good things which we learnt it from him. So now we will hear it from the master's voice.
Good evening. All of it is not true, of course. Tata Steel has learned quite a lot. I have learned only as much as I could learn. Thanks. So I'm going to today talk to you. I was thinking earlier what to talk, what subject to talk on this, how to actually present what knowledge we have gained. So that's what I will try and bring to your attention. So therefore I will written it like an account of an Indian experience. Don't bother so much to read it. I will share this particular PDF with all of you. So I will just highlight some few points in this. So first of all, I must thank Devyani. I think she helped make a case for a stamp charge battery. What justifies a stamp charge battery? So I asked this question: can you build a case for a top charge battery to me? Then I will build a stamp charge battery case. It actually has become so very apparent. A new cocoa battery installed, it is going to be a stamp charge battery. That's creating a strategic solution for India. And of course, building quality. So how we can get better and better quality coke to lower and lower cost and all that. I will tell you that this is a strategic solution to India's problems, actually speaking. So battery number 7 came is the first battery with stamp charging technology, and it was put up in 1989. First pushing was done in 1989. It operated until 2025. The last pushing was there in 2025. After 35 years of operation, about 12 million tons of coke production, the capacity of battery 7 was 0.37 million tons per annum, approximately. So it worked, produced about 12 million tons of coke, and then it had a one round of full wall repairs, which some coke ones have, some coke ones don't have. This battery had. And the reasons why it had full wall repairs also is clear to us. I'll try and describe it to you why it went to that process. Now, I think we don't have to go now. Superior quality coal requirements have come down and it's ended. I suppose the trend will continue hereafter. The second driving factor was the superior coal quality. Of course, this is evident. I don't want to talk about it. Third is the higher productivity and yield. Because in the oven you put the compact mass, you can put more coal, and because you can put more coal into the oven, you get more coke out of the oven. Kind of a promise. Current cocoa and batteries, stamp charge cocoa and battery which have come, may not be had. Or it probably has the best of minds in designing the coal blends, best of the system.
And the decision is always taken not by the technocrat, by the industrialist to charge something, anything, as per the whims and these things, mostly driven by the cost. So the rank, VM, swelling, talking of these words becomes a very misnomer for the decision maker to decide, and it creates more confusion. What is the solution to this problem?
I think now you may be knowing that I am associated with ACRE, in a company called ACRE India.
Did it, yes, we did it. And we have used also existing pusher machine, just added one additional charging machine. Yes, yes. And we have converted also the battery heating from top to side charging. No. Yes, yes, of course, but it works. It works, yeah, because of this coordination issue. Yeah, it works. Just wanted to mention.
Thank you. In fact, we have tried.
In fact, my job is a bit simpler right now because Deshpande Saab has actually given a very, very broad overview about this. In fact, 4 decades back, it was only indigenous coal we are using. And after 4 decades, we are going back to the same questions. We want to use it. But the reasons are different because in these 4 decades, so many things has changed. So it is a different challenge today, even to get some indigenous coal in our blend. So the picture is different. So we are going to talk about how to get coal, our domestic coal, for the coke making. That is what questions we'll try to find out, a few answers or few ideas. Okay, very quickly I'll take you through a little bit about coal and coke, important steel making scenarios and all. Then I'll take you 4 ideas, the themes of where we can get more and more domestic coal for coke making or use of domestic coal in coke making. So that is where I have planned. Of course, this is what we have already, knowing it, coal, that is the carbon, has basically 3 roles. It gives the heat, it is a reductant, and of course it takes load in blast furnace. These are the 3 activities of coal. Critical, I will say very critical. If the steel industry has to survive, there are few facts we need to know that these are the things we must address. On the right side, you can see almost 100% in most of the steel plant, the coal is getting imported, except Tata Steel is about 30% domestic, or maybe Shell having 12% domestic coal, the rest all imported. The coal injection, the PCI coal is also 100% imported. Even the DRI plant, where we use non-coking coal, there also more than 60% coal is imported, non-coking coal, 20 to 22% as, that also getting imported. So that's truly the current scenario. Now, I am talking about that coal is critical because when you talk about sustainability, there are 3 pillars, and in all 3 pillars, coal is a major player. Come to the cost, 35 to 45 cost of steel cost is coal. Come to environment, again major contributor is coal. The CO2 footprint is mainly because of the coal use. And of course, coal as an industry, it has a very, very significant impact on society, on Indian economy. There is a different role of coal. So overall, if you see that coal is playing very important role in all the 3 ESG, environment, social and governance, all factors they are there. So when steel industry is growing at a rapid rate, I'll say 8 to 10%, so you need to see that this coal part is taken care of properly. So that low VM HR coal, so LVC, so those are actually majority of our coal which is there in our Jharia coal field or Bokaro coal field and all. So this is the, but the coal which is mineable mostly is medium and some semi-sub coals are available. And these are very standard washing practice. Our coal is very difficult to beneficiate, very high in ash. So we need a very, very good technology to beneficiate. Again, we have experience of 50, 60 years on coal beneficiation. A lot of improvement has taken place, but even then, going to very low ash is very, very difficult. But certainly, what are the things going wrong, how we can do it, and this is very big area. If we can look into existing washery, and there are 8 to 10 new coal washeries are coming, so even that will add another 18 to 20 million tons of raw coal treated. So there will be an expansion. So these issues, the beneficiation issues need to be looked into. So there is again another basket, but what we need to do? We need to be little selective with the coal mines. Not all coals. ECL, MCL, there are mines having lower raw coal, maybe 27, 28%, 30% below. Such coals are there. I was also part of Tata Steel once. So medium coking coal, the West Bokaro coal, those coals, medium coking coal, very well fit for the stamp charging. And see, that belt has expanded like anything. Then weekly coking coal, semi-soft coal started blending into that. Then we started even adding non-coking coal into the blend. That's the flexibility the stamp charging technology has brought in. Non-recovery technology is another advantage. And when these two are combined, non-recovery and stamp charging giving even more flexible system. So now there are so much of opportunities to get many type of coals, including I am talking about that Indian coals. If you have slightly on higher as, we can do it. We can work on buying that. What we are right now even thinking, non-recovery blending and stamping, then why not even do hot stamping? This is very interesting thing we have seen that in a laboratory, that if we can do this, you are talking about preheating sometimes alone is difficult, but preheating along with stamp charging pre-carbon.
Is expected to reach 230 million metric tons by 2030, while the government keeps reiterating on the 300 number. So is the government being too ambitious or unrealistic? And secondly, on one hand, we keep talking about reducing our reliance on imports, being Atmanirbhar. But, the supply-demand gap for both met coal and met coke doesn't seem to be narrowing. So what does the future look like? Thank you.
Okay, the first one I have understood that, Indian target is 300 million ton steel. Hello. Capacity, and if you have a utilization 90%, then it is 270. But in reality, yes, 230 is very realistic figure. I am just projecting what really we will be. Not I am talking about what the aspiration target made, but that's a capacity. 300 million ton is a capacity. Okay, it's not production because it will be less than that. That is the first thing. The second one, what you asked? Yeah, so this gap is already very high. You have seen it, now from domestic supply, very limited. How much we are getting? 5 million tons and then captive few. So maybe 8-9 million tons of coal we are getting from India, and we are importing around 58 million tons of coal, coking coal, and together PCI and DRI 100 million tons of coal we are importing today. Okay, so almost 90% plus is imported. Okay, so 85, 80 and all. So that's what we are talking about. Hello. And this is a subject of national importance, discussed in multiple forums. There is a coking coal mission, already mission has been created. And as an action on that mission, there is 8 coking coal washeries are coming at different stage of implementations. Like Madhuban has already got implemented. There are a few washeries will come shortly. So next 3-4 years, we'll have another 15 to 20 million tons of coal washeries are coming up. But then that's not, even that bridging that gap will be not very high by doing that. More washeries has to come, and there are multiple suggestions coming, and especially from policy point of view, or for example, private participation already started. Okay, so that is one already initiated, and then policy and cost point of view, you have to give an advantage. Otherwise, overall, when you work out, because it's a very highly capital intensive. When you are going to invest, huge money is needed in that. That's why people are not coming. Investment is very high. It's a long-term decisions. So therefore, this policy is very, very important and government is working on those policies because it is identified one of the important areas. But of course, I'm not the person can tell you exactly what policies and all, but it's going to happen. Even revenue sharing basis also, there is another model already started. So those are a lot of things are happening in this case.
If there's time, just one more follow-up. So earlier in September, I had the chance to speak with Mr. Sandeep Pondrik, and one of the things that he mentioned was that CBAM is going to be a big driver even for India's trade in steel in the coming years.
Which one?
CBAM in Europe, Carbon Border Adjustment Mechanism.
Okay.
So while we are talking about enhancing our steel capacity, is it really going to be through green methods or just expansion in blast furnaces?
No, see, expansion is going to happen.
Professor Banerjee, thank you for your time and excellent presentations.
Thank you.
And now we'll go for another session. That is, it's a bit different. This gentleman will be Sujit Sengupta, will be speaking from Canada. We are connecting with Sujit Sujit is already connected here. He'll be speaking. He's from Admira Distributed Hybrid Energy. He is very much involved in, that hydrogen train in California which is running. He is commissioning that one. On my request, he came to have this presentation. And now over to Sujit. Sujit, can you hear us? Can you hear me? Yeah, you can. The time is yours. Please start. Thank you. You share the presentation and then we'll do.
Can you hear me? And can you see the presentation? So, good evening. Okay, just a minute. Okay, just 1 minute. Let me just check. Okay, so should I mute my sound, turn up microphone, or what? Give me a second. Okay, so screen share. We are just taking up from where we started. We are a research-focused company. We have worked in the field of green hydrogen and cryogenic technologies, and we are working in the hydrogen train that is being California's first, in North America's first commercial hydrogen train. We are just commissioning it. We are also doing various large infrastructure projects like the LRT in Edmonton, and as you know, Olympics will be held in California, in Los Angeles, so we are preparing California for the Olympics with the automated people mover. And we also have done large mining projects in northern Canada, as well as the topic of our discussion today. We have implemented a feasibility and a digital twin for a coke oven in West Virginia, US. So basically we know that transportation, mining and refining are very hard to decarbonize systems, and we need specialized technology, specialized capabilities to do that. So we have that expertise, and we have implemented such projects in Canada as well as in the US. So we have an experience on EPC, surveillance, auditing, research and development, design studies, and feasibility studies, and then the implementation of these large infrastructure projects where we do the complete design certification. If you look up ZEMU, Google, it will be, you will see the videos, and APM, see the videos of the projects that we do. So basically the topic of our discussion today is a digital twin for an integrated coke oven to hydrogen power and CO2 capture system. This is the topic of our discussion today. And basically we did such this project in West Virginia and in US for a coke oven that we will, as we go through, we will discuss. So basically coke oven gas, if you have to have good coking rates, then you have a lot of gas. So, and you have to utilize that gas. And it's better to clean up the gas at the source and then use it, source convert it to hydrogen and then use it. And then you reduce flaring, which again leads to emissions, and you have a good coking rate. So what we are proposing today is a digital twin. So we take our existing coke oven, we instrument it, create a digital twin, and then automate it, use the expertise AI expert systems to optimize it, and then develop it to a coke oven gas to hydrogen power and CO2 system. So we will be using the simulation, the AI analytics, the Internet of Things data, use for real-time optimization, predictive control, and decarbonization. So with AI now coming into the fore, the digital twin can be optimized and it can become a real-time control system. So this is the plant that we worked in West Virginia in the US. It had coke oven gas, which was sent by pipeline to a steel plant. And then because there was excess gas, they had to flare, so emissions was there. And so we came in and we devised such a system that we compress the coke oven gas. One of the main things of coke oven gas is H2S. So we had to put in a H2S removal system. And then what we did, we controlled the pollution at source, and we converted the coke oven gas to hydrogen. So we implemented a PSA system for hydrogen production, and then we used it for gas engines for generating power, as well as sale of hydrogen to the grid. And we could also use this hydrogen in blast furnaces. That is the concept proposal that I am suggesting. So we worked on this project, this coke oven gas project. So this, the numbers here are not in normal meter cube, because in US they deal with standard cubic feet. So, and one ton of 1 million standard cubic feet is around 28,000 normal meter cube. So what we did is each ton, to give some basics, we had an excess of 6 million standard cubic feet per day, coke oven gas. And each ton of coal produces around 11,500 at our site, to 11,500 to 13,000 standard cubic feet. And each a million standard cubic feet is valued at around 3,000 US dollars. So we had the option to generate 12 megawatts from 6 million standard cubic feet per day. The project outlay was around 40 million for an 18 million standard cubic foot per day to convert to electricity. And the investment was around 30 million USD for hydrogen recovery, and the ROI was 35%. So what are the physical assets we had? We had the coke oven, we integrated the PSA hydrogen plant, and the engines. We did not use the turbine, but the turbines were used in cooling and capture of CO2 that we did. And then we had the data acquisition, which is a very important part. In fact, it's the first step of the process of creating the digital twin and optimizing the system. So we had to sensors for flows, temperature, gas composition, and emissions. Then we brought in edge and cloud computing analytics at the source, at the site, and then we created the AI twin for the supervisory model of integrating the subsystems for efficiency and emissions. So this we did in several projects. We did in the mining project in northern Canada. We did it for this coke oven project, and we use it for our light rail transit systems, which are automated and peopleless. Like human, there's no human control on the trains. So what are the parameters? One of the main parameters is the wall temperature of the coke oven. So we monitor and optimize that. The flue gas is a very important factor, the flue gas, oxygen level, and the coking time. Like we would like to have lower coking times, and that will generate more gas. So we have to have the good use of that gas. And this gas is very rich in hydrogen. It is 55 to 60% rich in hydrogen. So it is a very, very good source of hydrogen. That's why we are suggesting we clean up the coke oven gas, convert it to hydrogen, and use it in the steel plant or to generate power and hydrogen, and implement a CO2 capture system here so that we can capture and either stored in underground liquefiers the CO2 or use the CO2 for various applications that we can develop. So now the AI and the analytics framework that we did. So predictive maintenance is a big thing, and if we have machine level models to detect valve and compressor faults, then it's a big win for us. And then if we can AI to have the real-time control of the PSA for the hydrogen and the furnace temperature, and have learnings, reinforcement learnings, then it will only help us in optimizing our process. So and now with capabilities today, we can have a scenario simulation, evaluate the yield, efficiency, CO2 reduction, etc. And also we can have like the 3D dashboards as well as visualization in terms of cameras and collecting the infrared signatures and optimizing the process through it. So what we saw in our projects is that there were improvements in availability, failure, maintenance cost, yield, and energy. And it was a quick win to create the digital twin, and we created it in 12 to 24 months. So the digital twins plus the predictive analytics that we can do today can uplift the uptime and quality, and it can accelerate the standard operating procedures and decision support. So what we saw in all our projects that we did was the downtime came down 20 to 30%. The maintenance costs came down 15 to 25%. The availability of the systems, both the mines as well as the coke oven as well as the LRT systems, the light rail systems that we work on, availability we were able to 83%, and with the introduction of AI analytics, we can reach availabilities of around 90%. That's what we project. So there's a reduction of downtime and there's a reduction of cost of production. So what was the strategic AI roadmap? We said that we will deliver this digital twin in 12 to 24 maps. We'll start with pilots, integrate data analysis at the edge and cloud level, integrated with the ERP systems, and then scale up the whole system to deliver a new product. So what we did was the phase one was we had to data and sensor infrastructure automation. Then we had to develop the model. For 9 months, we spent that, and then AI and machine learning integration we took for 12 months. And the phase 4 was the commissioning, then the phase 5 was the expansion into carbon capture and creating a microgrid into the whole system. So about the financials, the hydrogen output was around 7.2 million standard cubic feet per day. We captured CO2 around 150 to 600 tons per day. We generated power 8 to 20 megawatts, around 20 megawatts, and we avoided CO2 of 200,000 tons per year. So this is a big thing because today we want to have green steel and a lower carbon footprint. So avoiding CO2 is a big thing. So up to 90% of CO2 emissions were reduced. And another big win was that the flaring of the coke oven gas was stopped. So this was 2 big wins, but which we could project and develop through the creation of the digital twin as well as the optimization of a design through it. So, as I said, that we had the data and sensor infrastructure. That is the first thing, that we have to have the sensors. Then we have to develop the model and then integrate machine learning into it. and then the commissioning and training, and then the expansion of the carbon capture and the set points and alerts were sent back to the plant. So we did that. So now a little bit of a background now, like AI can be applied in steel making and in like basically in EAF and BOF. So we have done it in EAF situations, and what we project is the same thing can be done in BOF optimization in terms of energy and endpoints, and it can be applied in casting twins and rolling also. So the digital twin has a big application, and we have been implementing these digital twins for a period of time. But that time we did not have the natural language processing and AI in our mix. But today, if we can put the mix of natural language processing and AI into the digital twin, it becomes a very strong force. So basically what we are projecting is that energy can, from our projects, what we have seen, energy can go down 10%. The use of electrodes in EAF can go down at 15%, and tap-to-tap time can go down by 9%. This is what we have seen from our models. And the second point is that today with AI, we can vision AI. So basically we can take infrared cameras and monitor the earths and slags and foam from creation. So this is a big win also. And of course the scrap mix can also be optimized to improve consistency. And then natural language processing and generative AI gives a big input to it and it improves the whole delivery of the whole system. So auto-generated reports, training, faster root cause analysis, and automation and operator. The operator can be helped with co-pilots also. So that is a big win also. So the deployment blueprint is we instrument the critical failures, secure the data, create a pilot, validate the pilot, integrate the whole system, and scale it up. So as we know, this is a bit of a background. Steel industry emits around 7% of the global CO2, and we know that in India we will have the blast furnace route for the next 20 to 25 years. So, and this is coke intensive. So it is very important that we have a very optimized and very modern coke oven system. This will help us to reduce our emissions as well as our carbon footprint and deliver green steel. And that is where hydrogen comes in. If we can clean the coke oven gas at source and use the hydrogen, then our steel becomes clean. So there has been some testing of hydrogen injection in worldwide. So the next slide will tell us that. So this is what we have seen from our literature search. So Japan, Nippon Steel has done it. Germany, ThyssenKrupp has done it. In India, Tata Steel did a four-day trial, I understand, with 20% coke replacement. And then in China, Baowu and Hycroft have done it. So these are examples where in all our projects that we did was the downtime came down 20 to 30%. The maintenance cost came down 15 to 25%. The availability of the systems, both the mines as well as the coke oven as well as the LRT systems, the light rail systems that we work on, availability, we were able to 83%, and with the introduction of AI analytics, we can reach availabilities of around 90%. That's what we project. So there's a reduction of downtime and there's a reduction of cost of production. So what was the strategic AI roadmap? We said that we will deliver this digital twin in 12 to 24 maps. We'll start with pilots. integrate data analysis at the edge and cloud level, integrate it with the ERP systems, and then scale up the whole system to deliver a new product. So what we did was we had, the phase one was we had to data and sensor infrastructure automation. Then we had to develop the model. For 9 months, we spent that, and then AI and machine learning integration we took for 12 months. And the phase 4 was the commissioning, then the phase 5 was the expansion into carbon capture and creating a microgrid into the whole system. So about the financials, the hydrogen output was around 7.2 million standard cubic feet per day. We captured CO2 around 150 to 600 tons per day. We generated power 8 to 20 megawatts, around 20 megawatts, and we avoided CO2 of 200,000 tons per year. So this is a big thing because today we want to have green steel and a lower carbon footprint. So avoiding CO2 is a big thing. So up to 90% of CO2 emissions were reduced. And another big win was that the flaring of the coke oven gas was stopped. So this was two big wins, but which we could project and develop through the creation of the digital twin as well as the optimization of a design through it. So, as I said, that we had the data and sensor infrastructure. That is the first thing, that we have to have the sensors. Then we have to develop the model, and then integrate machine learning into it, and then the commissioning and training, and then the expansion of the carbon capture and the set points and alerts were sent back to the plant. So we did that. So now a little bit of a background now, like AI can be applied in steel making and in basically in EAF and BOF. So we have done it in EAF situations, and what we project is the same thing can be done in BOF optimization in terms of energy and endpoints, and it can be applied in casting twins and rolling also. So the digital twin has a big application, and we have been implementing these digital twins for a period of time, but that time we did not have the natural language processing and AI in our mix. But today, if we can put the mix of natural language processing and AI into the digital twin, it becomes a very strong force. So basically what we are projecting is that energy can, from our projects, what we have seen, energy can go down 10%. The use of electrodes in EAF can go down at 15%, and tap-to-tap time can go down by 9%. This is what we have seen from our models. And the second point is that today with AI, we can vision AI. So basically we can take infrared cameras and monitor the earths and slags and foam from creation. So this is a big win also. And of course the scrap mix can also be optimized to improve consistency. And then natural language processing and generative AI gives a big input to it and it improves the whole delivery of the whole system. So auto-generated reports, training, faster root cause analysis, and automation and operator. The operator can be helped by co-pilots also. So that is a big win also. So the deployment blueprint is we instrument the critical failures, secure the data, create a pilot, validate the pilot, integrate the whole system, and scale it up. So as we know, this is a bit of a background. Steel industry emits around 7% of the global CO2. And we know that in India we will have the blast furnace route for the next 25 to 20 to 25 years. So, and this is coke intensive. So it is very important that we have a very optimized and very modern coke oven system. This will help us to reduce our emissions as well as our carbon footprint and deliver green steel. And that is where hydrogen comes in. If we can clean the coke oven gas at source and use the hydrogen, then our steel becomes clean. So there has been some testing of hydrogen injection in worldwide. So the next slide will tell us that. So this is what we have seen from our literature search. So Japan, Nippon Steel has done it, Germany, ThyssenKrupp has done it, in India, Tata Steel did a four-day trial, I understand, with 20% coke replacement, and then in China, Baowu and Hycroft have done it. So these are examples where we...
Yeah, Sujit, there is a question, if you could hear me.
Yes, I cannot hear clearly, so...
Okay. Hello, can you hear me now?
Faintly, just a little bit more volume if you could.
Okay, sure. I'll just bring the mic closer. So hi, I'm Shivam from S&P Global. I had a very small question. So you mentioned that India is going to continue in the BOF route for the next 20 to 25 years. And then you also spoke about green hydrogen as an alternative. So green hydrogen, what is the prospect of green hydrogen in a country like India, where it is only feasible if the cost comes down to like $2 per kg? So if you could just elaborate on your statement there.
Yeah, a very good question. It is a very good question. Abundant in the steel mills, and they use coke for coke in the blast furnace as well as the gas. So now, this coke oven gas, as I mentioned, is very rich. It has around 60% hydrogen. So if we can clean up the coke oven gas, remove the H2S, which we have done in this coke oven in West Virginia. So if you can clean up the gas and then have the hydrogen component and use the hydrogen component for the blast furnace, the blast furnace operations becomes green to the extent possible. And some pilots have been done. So, and your cost factor is, if we can get green hydrogen, clean hydrogen, or blue hydrogen from, not green, but at least blue hydrogen, that is with CO2 capture and H2S removal, then the cost that you are talking about, $2 to $3 per kg, is achievable. It cannot be done with electrical infrastructure and electrolyzer at the moment, but we are working on like small modular reactors and more electricity and cheap electricity. That we are working on. Projects are being developed. But for India, the opportunity is that you already have coke ovens, you already have blast furnaces. It's just a matter of cleaning up the coke oven gas. And I am suggesting just clean up the flaring, stop the flaring, use the excess coke oven gas and do a pilot. And then if the pilot succeeds, implement it in a larger scale. And even before doing the pilot, build a digital twin and test everything out. So that's what I'm suggesting.
Thank you.
Yeah, anyone else?
Looks very lucrative. But is there any safety hazard and is there any concern which may be a problem for the future?
Very good question. Safety is a very important factor, and using the digital twin that I suggested and cleaning up the coke oven gas to hydrogen. Hydrogen is a very stable gas. It's not a stable gas. So the safety, in fact, using hydrogen will improve. And the safety by using digital twin, because you will have root cause analysis, scenario analysis, the safety of your whole system will improve. So the safety will improve instead of going down. So it will be a better system. That is my experience.
Yeah, that is what, me and Sujit were discussing. If any of these coke ovens people that we are doing, he is willing the research, and do it so that one, if it is implemented, later on people will come. That is the reason I requested Sujit to give a presentation. You know, many people here, if they feel if it is not implemented here, it cannot be implemented anywhere else. So here he has implemented it. Here he has implemented it. He has seen it is being done. And also he is going to help us doing it here. So that is the reason we said that, okay, if there are some people, if you could help. Yeah, Amor, now you have a question. Yeah.
Sir, what is the capacity of Coke Oven where you have implemented this?
Per day.
28,000 per hour.
No, for per day. Normal meter cube per day.
So it's a small one, sir. Capacity Coke tonnage is a small one. Like we are going to build a huge, roughly say 1.5 million ton Coke ovens. But for that, I think this system is not ready.
The thing is that your question is very good. I want to start small, develop the pilot, and then implement in a bigger way. That way, the failure rate
Pilot we can think of. Pilot we can think of, sir. Yeah.
Yeah, so just do the pilot, and then if it succeeds,
Amitabh.
expand it.
Yes, sir. We have a technology people with us. We'll discuss internally.
You know, here it is, he's Amor, he's the chief of Coke Ovens here in Tata Steel, Kalinganagar, and they are discussing.
Do we have all the instrumentation to create the digital till? This is an exercise which can be done without a lot of cost. And once we have the instrumentation, because you build this Coke oven only once, so you should have all the instrumentation needed for the digital till. Once you have that, then you create that, then it's a software thing.
Yes, sir. You give us a list, we'll try to implement it and we'll see. Actually, sir, we had tried one digital twin for our CSR improvement model, but somehow there was so much of variation in the coal quality, seam to seam, mine to mine, that we couldn't conclude it. So if you are telling this time for the hydrogen separation from the coke oven gas, we are open to try again, sir.
Yes, we can do that. We can develop a good PSA system. We can work with the big multinationals that are working in this field in terms of Linde, Air Liquide. I worked in, and we could really develop. See, the thing is, it's a beautiful thing if we realize it. Coke oven gas has a lot of hydrogen, but coke oven gas is not stable, as you said. So if you can clean up the coke oven gas, remove the impurities, then use it as hydrogen, then it becomes cleaner and safer. So this, if Tata Steel does it or any other company does it, it will be a game changer.
Yes, sir.
That's my feeling.
We'll try, sir.
Yes, Sujit, you know, Amor is here, he's heading the coke ovens here. Next time when you come and you meet him and he's given the offer for having a meeting, we can take it forward.
Sure, no.
Good that, yeah.
No problem. And we can do it from here also. The meeting, we don't have to wait for me to come to India in December. We can have a Teams meeting. I can always arrange that. That's not a problem
meeting. You know, we'll fix up a date with Amor, you, and we'll take it forward. And Mr. Chatterjee, if whoever wants to join, they can do it. Thank you very much. Any other?
Internally discuss it and let you know, sir. I'll internally discuss it, yes, sir.
Sure, no problem. Thank you for your time. Thank you very much.
Any other question? Yeah, fine. Thank you, Sujit, for an excellent presentation and creating interest amongst the audience. That is what we wanted, and also we wanted to go it. Thank you very much, everybody. Thank you.
Thank you, everyone, for your time. Take care. Have a good day.
Messrs. SSC for their short presentation.
Along with its byproduct plants, CDQ, and material handling system. Today, or this year, we'll be a 20-year-old company, and to just share a milestone, our founder, Mr. Sharad Agarwala, he started this company with the commissioning of the coke ovens of JSPL Raigarh way back in 2005 under the leadership of Mr. Sabat sir here. And after that, he's standing in front of both of you stalwarts and presenting our organized version today of providing value-added services for the operation maintenance activities of coke oven. Two of our other milestones, in 2020, we took over the operations of Tata Steel Meramandli plant, which is a 7.6 meter tall battery, the second largest battery in the world, under the leadership of Buntra sir. And as we speak, we are commissioning the largest stamp charge batteries of the world, that is 6.8 meter battery of JSPL Angul, under the leadership of Shisani sir. So basically, we are the people who execute all the planning done by the biggest brains of this industry. And in lighter terms, we bring the human element to this technological marvel called the cocoa and batteries. The challenges that we face in our day-to-day activities, first of all, is the manpower itself. So there are a lot of activities. Okay, can we come to the next slide? Before that, today we are a company, no, the next one. So we have around 14 clients across the country, which is eastern part of India, southern and west. Thank you very much.
Sustainable future to reduce emissions at all industries who are using hydrocarbon fuels. They are currently in research on coal, where savings to the tune of 7 to 8% have been consistently reported. Now to Mr. Ambisan.
Thank you, sir. Good evening, everyone. M1 booster, which is used with gasoline, diesel, furnace oil, light diesel oil, low sulfur, LHSH, SKO, and other heavy oils. And we have created one for gaseous hydrocarbon, which works with LPG, LNG, CNG, PNG, methane, and biogas. So when it comes to steel industry, they consume around 803 TMT per year. And we think that we can save up to 64,000 metric tons per year, which they can earn around 1,71,635 carbon credits. As you all know, carbon credits are in place, government is implementing it. So in coming years, this will become the norm. There's a case study we have conducted in Sanmar Matrix Metals. It's one of the foundries in Tamil Nadu. We have achieved around 70.4% in 23-24 financial year. So that was in SKO. And here is the plant consumption versus tank consumption. If you can see, there's a difference. The left one.
Yeah. Big round of applause. Yeah, one more gift, sir. One more memento. Thank you, thank you, thank you.